So, how is our assignment going on? I'm supposed to put a submission date by now because it's already 25th. I'm supposed to be by 30th to the 2nd of December. I'm supposed to start saying, but I'll put it officially on Slack. So this morning, um, it's not going to be me taking you all, like I said before. It's going to be someone that it's really dear to my heart. Um, she's really dear to my heart. I don't know if you all know her. I know her as Sharon, and she's known on Twitter as Sharon. Funny enough, I've never met Sharon in person. I think I just know her on Twitter, and when she was supposed to resume in my former place of work, it was like a week before I left, I relocated. So yeah, Sharon is someone that is very intelligent. Like I remember during our interview, I was bent on my boss's head that I really want Sharon to join us because she's very smart, she's very intelligent. She's someone I would say she sabi this work. You get that's where I would describe her. So I'm sure that one thing about me, I always believe that someone that really knows it just beyond just cramming it, but knows it. Like she can go in depth to give you like detailed knowledge about what machine learning is. She'll be the best person to introduce you to further. I know we've discussed it briefly when we talked about data pre-processing, but she will be coming to really show you what machine learning is about. And I believe that because um I've seen her speak before. I've seen her being able to explain really complex things and be able to simplify it. She'll be the best person to really show you machine learning beyond what you see online, like really simplify the whole concept. So without further ado, please can we all give a round of applause to Sharon Benji? Am I correct with the pronunciation? Please can we unmute our mic? Say welcome, Sharon. Thank you for taking out your time. Like I always say before, whenever I bring these people, they don't collect money from me. I don't pay them. You know, it's from the love of their heart towards helping people. And they come here and they sacrifice their time. And she's coming twice. So please let's try as much as possible to make the class very interactive, very lively, so that we can learn more from her because she has in-depth of knowledge. Like during our interview, Sharon was saying things that I myself I didn't even know about as of that time. So you guys should ask that question. Drill Sharon, ask Sharon question. She can You can never over ask Sharon question. Yeah, thank you so much. Thank you so much, Sharon. Welcome once again. Welcome to the class. This is this they are made of people that are either early in their career or transitioning. We usually get to in an average of 25 people. So we're 18 now, so within by the next 30 minutes you start some out about 25 people. But in total we are 30 something in class. So some people have taken permission that they can't always be in class, but that we create YouTube videos that we can reach a larger audience. Welcome once again, Sharon.
Thank you so much, Nika. Like this was, I was just like, is it me that you're praising like this or someone else? But I really do appreciate it. Like, I'm happy to do this, right? And Onyeka is my person, right? Again, I was even looking forward to meeting you, and it's unfortunate that, well, it's on the good side actually, but for two of us, so unfortunate that you left earlier than I came in. But yeah, hello everyone, and thanks for giving me this audience. Right. So as Anika mentioned, we're going to be discussing machine learning. But before then, we are going to start off with feature engineering because feature engineering is like the step before we proceed to machine learning. It's something that we need to totally understand, right? So I'll share my screen. I'll take it slowly. If you have questions, feel free to interrupt me, right? You may not always have to type, but if you prefer to type, it's totally fine. I'll always come back to check, or Onyeka can always let me know that there's a question, right? So again, I would like this class to be interactive, right? We're going to discuss, right? I'll teach and then feel free to ask the questions. Um, so I don't know, Onyeka, is this usually hands-on, or should I just go ahead and explain, and then later I'll share the notebook with them, then you can experiment?
Yeah, so you could, when I did my own, what I did was to explain it, like explain it, and then
Yeah,
on they got like the video so they could practice, and then if
okay,
they had issues, they sent it to me. So they could only
okay,
send it to me, even if they can't reach you directly.
okay. All right, that'll work then. I'll also share the notebook after the class and the data as well. All right, thank you, everyone. So I'm sharing my screen now. All right, so I assume that you can see my screen, and I'll go straight to what we have for today. Oops. All right, so let's get started. Now we are heading towards, based on the curriculum for this program. I've seen that we've looked at data visualization, we've looked at um, EDA, right? And now we are tilting towards ML, right? Um, so next week we would go deeply into machine learning. But for today, like I said, we'll start off with understanding the data that we need to feed into our ML model. All right. Now, number one question I want to ask anyone, please feel free to unmute, is that is there any such thing as too much data? Like, can you have data and be like, ah, well, this data is now too much? Like, you have excess data sets. Is there anything like too much data, or it doesn't matter? Like, data is always data. Anyone, just let me know your thoughts. I have my own answer. I'll tell you, but tell me yours first. I think there's a comments. Yeah, please go ahead. Feel free to unmute though.
Okay, good morning.
Good morning.
I think you're in an assignment, you've been given an assignment, you are trying to analyze it. You found out that the geodata is almost 1 million plus, and we feel it's too much. That's what I think. So I think it's too much data whatsoever.
Awesome. So you agree that there's too much data, right? Does anyone have any opposing thoughts? If there's silence, then I agree that we are all in support of what Emmanuel said. Yeah, Adela, go ahead and speak.
Good morning, everyone. Good morning, Sharon.
Good morning.
Well, I believe that as like yeah, we actually generate a lot of data, but I also believe that there shouldn't be anything as too much data for a project, so that if you want the project to be inclusive, like you want everybody to be well represented, I think that
Mhm.
there's no such thing as too much data. Thank
All
you.
right. Awesome. I like that we have two different perspectives or opinions, right? So now I feel like you're coming from the point of avoiding bias and having some level of representation for every group. But then we have cases whereby although you have a representation for a group, maybe you have a gender column, or you have social class column, or you have tribes, all of that, right? There could be more columns that might not really be important to what you're working on, even if the data represents everybody. Do you agree with me, Adiola?
Let me unmute. Yes, I do. I do.
Awesome. So now I'm going to break this down a bit. Now, there's a thing as too much data, and there are actually challenges with dealing with them. Imagine having a data set with over 50 columns, right? Emmanuel came from the point of having so many rows. And that's a problem because by the time you think of processing all of this, you look at the computation, you look at the time you have to spend, you don't even know which one to even start with. In fact, you even get overwhelmed, right? Now, the challenges with too much data is data overload, the difficulties that comes with finding the information that you need. Then we have noise. I thought you have so many data. There are so many irrelevant values, features that are not really necessary to the core thing that your project is trying to achieve, right? Now it becomes more difficult to even know what exactly you're looking for, and even trying to ascertain that what you're returning is actually valid or accurate. You have issues with analysis, like what Emmanuel said. You don't even know where to start because you have a whole lot of rules that piled up looking at you. You also have storage and management issue because the larger your data sets, the more storage capacity, right? Why there is sort of like a thin line between picking enough data and letting go of valuable data. It's important that you understand the domain that you're working with and knowing what exactly you need, right? Then we also have issues of security. The more sensitive data you have, the more it demands you to protect that data. All right, so now let's go back home. We are looking at machine learning. Now we are assuming we're in the position whereby our boss has told us, hey, I want you guys to work on this project. Data guys, data engineers have helped us to spool the data from our database. Now, our data scientists, we have the data looking at us in our Jupyter notebook. And then the question is, where do I go from here? Now you have a large data set. You know that you want to build a model. Now in this work, the use case we're looking at now is predicting churn. We have a telecommunication company that they have customers, and some customers have left some time ago. Some customers are still with them. Now, what's the probability that a new customer, or even the customers that are still with them, what's the probability that this customer will either continue to transact with us or the customer will stop transacting with us? That's what we refer to as churn or no churn. If the customer stops transacting, then they've churned, they've left us. If they keep transacting, then they did not churn, they are still with us. But because we want to keep retaining our customers, it's important for us to build a model so that people that have the probability of churning, we can probably target them, market to them, understand their needs, or whatever that the marketing team may want to do to retain those customers. All right. So now we go to the next part of this. Now we are looking at the advantages of having a concise data. When I mean concise, I mean having data that is straight to the point, that contains what you exactly need. Number one is that the data is lighter, it's easier to process. You don't need large computations for that. Number two is that it's easy for you to reach your goal. If you want to do data analysis, machine learning, store data, you know what exactly you're looking at, you know what is important to you. Now, it also reduces computation costs, like I mentioned before. And again, we can go home on time because the more you are just gazing at the data, the more you sleep and wake up and the data is still looking at you. All right. Now, in this context of machine learning, the act of reducing your data to the concise format as required by you is called feature engineering. Now, emphasis on by you because you are the data scientist, you are the data person um, that's working on this project, right? And then you have definitions of what could be relevant and what may not be relevant. If you're unsure, sometimes it's important for you to ask questions. Maybe you have to reach out to the business team, find out what does this column even mean, whether it's useful or not useful, right? Um, but if you have strong domain knowledge, you might be comfortable enough to make decisions yourself, or if it's your personal project, all right? So now I want to also make it clear that there's a kind of difference between data cleaning and feature engineering. Like I said, feature engineering is reducing your rows, your column, sorry. You have so many features. Remember that a column can be called a feature, right? For example, for churn, you might have the dates the customer started working with us, that's their start dates, right? You might have the gender, you might have the age, all of these are the column names, which in this case we refer to as features. So feature engineering is how do you manipulate these features? How do you reduce these features? How do you normalize these features. What do you need to do to these features? Get to me for your model, right? So, like I said, it's kind of like a difference between data cleaning and feature engineering. Data cleaning is basically the high level thing we do when you do when you load your data. There are some high level things to sites and you know that you need to treat them. For example, you check if you have null values. You try to like, okay, how do I clean these null values? Do I need to drop them? Do I need to fill them with a value? And then you probably check whether the spellings are correct, if there are errors in your spellings. You check if you need to put all your columns as lowercase or uppercase. All of those things that we do to make sure that our data is ready. In fact, I would even define data cleaning as something you do to an extent that you can now visualize your data. If you try to visualize your data and you don't get error, then I'll assume your data is clean. Now, but feature engineering is now this next level. It involves an interaction with your model. Sometimes you do your feature engineering, it's not even perfect. You build your model, you don't get exactly what you want. You come back to feature engineering again. So you just the back and forth between your data and your model until you get what you want. Okay, so I want to find out if there's any question. I hope I've not confused anyone. Please ask me any questions, raise your hands, anything, or mute, drop a chat.
Sorry, is there a difference between feature engineering and
Sorry, your voice is low. What did you say?
between feature engineering and analyzing
Okay.
a data?
Okay, saying what's the difference between feature engineering and data analysis, right? Is that what you asked?
Yes.
Is that what you said? Difference between feature engineering and analyzing the data. Is that what you said?
Yes, sir. Yes, ma'am.
Okay, okay. Now, again, what's the goal of data analysis? Data analysis helps to review the contents of your data, right? Oftentimes, it's backed with data visualization because it's easier for you to see what your data entails, all right? Now, feature engineering, if you are not tilting towards building a model, you don't need to bother yourself much with feature engineering. Again, you don't need to bother yourself much, emphasis on much. You might bother yourself, but not much. All right. So now, what data analysis is doing is just exploring, visualizing your data. For example, told you that we could have like gender and age for this guy, this data set of churning, right? Now you could want to see, okay, what the distribution of the age brackets that are churning, what the distribution of the gender that are churning, right? Now, if we're looking at the female people, what age brackets among the females are churning? Maybe that could even give an idea to the marketing team on the type of product to market to them. Maybe they're younger people, maybe Gen Z people are the ones churning. That means probably their product is not does not give the vibe of the young people, right? Maybe it's maybe for example, sorry, I hope nobody has any relative as First Bank here, but First Bank could be an example, or Union Bank. These are banks that when people hear of, they just assume that it's old people's bank, right? So it doesn't give the tone of a young generation. So by the time you check the distribution of people that are leaving, it can reveal to you that okay, we need to focus more on the young guys. How can we make our business attract younger people? That's the goal of data analysis. It reviews internal patterns in data sets. Now, but feature engineering is a bit more different, or a larger, in a larger frame, more advanced. Feature engineering now is that okay, we have our data distributed in. Let's look at how much is every customer give. How much are we making out from every customer every month, right? So one customer, we could be making 10,000 naira from a customer. We could be making 1 million from another customer. We could be making 20 million from another customer, right? These are different values. Now, feature engineering will be like, the range of these values are not even low. We're having very low values and very high values. How can we compress all these values to be within the same range? Now, if you're doing your data analysis, you don't need to bother about that because it's even more important for you to even see the customers that are giving you more values. But feature engineering will even want to squash that value to be within 0 and 1. I see. So it's at that point, as a data analyst, it's not relevant for you to do that. All right. Now, secondly, is that feature engineering could be some other things like there are outliers here, right? Now, to a data analyst, an outlier could be like, I don't know, but in some cases it could inform a data analyst. But for in machine learning cases, you might want to handle those outliers. So now feature engineering is more on what you do to make your model perform better. We are now looking towards favoring our ML model, but data analyst is looking at things that will inform the business people. I don't know if that's clear or if it's still a bit confusing.
Yeah, I understand. I understand. Thank you very much.
Awesome. So now we can dive in, right? I think the answer is yes. So now let's go straight to feature engineering. We've been saying a lot about feature engineering. What exactly is feature engineering? Feature engineering is the process of creating new features or transforming the features that you have to improve the performance of a machine learning model. I think that's a very straightforward definition. Either you use the features you have to create a new one, or the one that you have, you just transform it so that the performance of your model will be good. All right. Now, but before we go deep into feature engineering, what exactly is this machine learning guy that we're talking about? Like, seems like he's the big boss, and then we're just trying to like pave the way for it to, access or gets there, right? So, what exactly is this guy called machine learning? But I'm going to be very basic so that next week we can spend more time on machine learning. All right. So now I gave an example of the churn guy. A simple machine learning task is trying to classify the status of an event. All right. Now, for example, every customer that what's the probability that for any customer that we have, what the probability that they will stop transaction with us? If it's one, then that means more this customer might be leaving us very soon. If it's 0.5, it means that this guy may leave, may not leave. If it's 0.3 or 0.2, it means that this guy will never leave us. Is our own person, right? So now this is what machine learning does. It's that probabilistic guy that just tells you, hey, I'm looking into the future. I think this guy is going to leave us, right? But how does it know, right? Machine learning models were trained on something that allows it to understand, just the way as human beings. Someone will come and ask you, guy, please help me with 20K. We already know that they are not going to pay back, right? We already know. So, but how do we know? It's based on historical events. Maybe your classmate some time ago has asked you for money and they bailed, they did not refund you. Maybe your colleague or your neighbor has asked you for 5K, they bailed, they did not refund you. Other people around you, I'm telling you, guy, stop lending people money, or they don't ever pay back. All of these things are events that have been happening in the past that you've learned your lesson. And now if a new case should come in front of you, maybe your cousin or your junior brother, no, maybe not just a junior brother, maybe your distant cousin now comes around to ask you for money. At that point, there are chances that they will not pay back because you already know that based on pattern, right? The probability of this person paying me back my money is very, 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 very low. That's what machine learning does. You get data that relates to that problem they are trying to solve. You feed that data into something called an algorithm. That algorithm tries to match pattern. If this guy did this and this guy did that and this guy did this, well, if this one did that. So it tries to like create all of those patterns, right? And then if there's a new situation, it tells you that the probability of this happening is either low or high, and then it's left for you to do whatever you want to do with that prediction. So now the question now is that how do I now know what features are important? Again, features are columns. I'm going to show you what a data frame looks like. I know we're already familiar with it, so but I'm going to explain in details in practical so that we are going to understand. So now let's dive straight in. This is what our data set looks like. We have so many rows. We have about 7,000 rows, and then we have 21 columns. Now, in real life, we want to know that for every customer that has this and that with each one, it's easier for us, or it's more ideal, or it's better for us to have fewer features that does the actual thing than having a lot of features, because that means for every new customer that wants to predict if they will churn or not, we need to provide all of these values. And sometimes getting all of these values for every new customer might take time. You get, it's easy for us to have like fewer values that is to just pull from the DB, right, and then run our prediction on. So that's the idea on feature engineering, right? Getting features that would actually help us get a good model, right? And make it easier for us in terms of inference when we want to make use of the model. Models, features that we can easily get. Okay. So now we have 21 features. We have the gender, the ID, gender, if this is a senior citizen or not, if the person is a partner with the business or not, right? Like the person has a partner, I'm not sure. But then if the person has dependents, tenure is how long this customer has been with us. Phone service, there are just quite many. And then we have the big guy here, the churn. This tells whether this guy churned or not. If the guy did not churn, we are safe. If the guy churned, then there's a problem. All right. So we have this history of our customers. These are people that have left us. So once you use this data now to train a model, so that in future for all of these other customers that are no, 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 can we now check if dates are likely to churn or not? All right. That's the goal of a machine learning model. So now, we can now talk about the types of feature engineering. If you're paying close attention, you realize that I gave different scenarios of feature engineering. So I'm going to break it down into three, and then we're going to work with these three guys. But so far, is there any question before we proceed? Okay, so I'll take the silence as a no. All right, so now we have three major forms of feature engineering. We have number one, feature creation. Now, feature creation is just generating new features from our data. For example, we have this data here. We could decide that, okay, if we have monthly charges and we have total charges, instead of having these two guys together, can we not just get like the average charges? Probably we'll just do total divided by monthly. So in that way, we've created a new feature. All right. So that is also part of feature engineering. Either you're creating a feature from existing features, right? Or you're using your own domain knowledge, right, to carve out something. All right. So now you could see maybe there is a column that comprises of so many things together. You could decide to break it up. So it depends on what the data contains and your own knowledge about the focus of this project, about the data, your experience in churning, your experience in telecoms, and all of that. So now the next kind of feature engineering is what we call feature transformation. As the name implies, we are transforming, we're moving from this guy to this other guy, right? So feature transformation is just basically, when you look at what your data has already, what can you do to change the format? If you alter the format of your data, then you are transforming the data. For example, we're having so many no, 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 no. What if for every no, we replace no with zero? For every yes, replace yes with one. You've transformed your data. What if, like I mentioned before, we have um a wide spread of values ranging between 1,000 to 20 million, right, for a column? What if we compress them to zeros and one, like between they fall within the range of 0 and 1? That's also feature transformation because we're changing the format of the data in a way that if someone saw this data initially and they come back and see it, they might not even recognize that it's the same data set, except that the column names might be the same. All right, so that's what feature transformation means, right? So now feature transformation is of two types: data normalization, which is the part where you are shrinking your values to be within a particular range. The range could be between 0 and 1. It could be between -1 and 1. It could be that you want the mean of this column to be just 1. Can't be more than 1. You want the standard deviation to be 0, right? So these are things that you do, and then you consider you are normalizing your data set. But I am going to explain all of this in details. I mean explain, I don't mean in theory. You're going to see the code, we're going to run it, apply to the data sets, all right? But I just want to prepare our minds on what we are going to expect down. Then the data encoding, the part I spoke about for categorical columns, computers don't understand English, they understand numbers. So for those categorical columns, we can be nice to help this guy convert those categories to 0 and 1. Although there are machine learning algorithms that don't need you to do these things, like XGBoost, you just feed this in and then it does the conversion itself, and it's very easy. But we can't just rely on one model, right? Unless if you're super sure that it's just that model you're using and enough, right? So why don't we clean the data so that you want to try out different models, you won't start having errors here and there, right? So now this is what we call data encoding. There are different types. We have the one hot encoding, we have the label encoding, which I'm still going to explain later. Then the third guy is what we call feature selection. Now this is the crux of this whole feature engineering. How do we pick out the most important features? There are different ways to achieve this. We have of course, the domain knowledge part plays a part here too, where you can just see data and then you know that okay, this one are enough, right? But sometimes you need to do some more advanced analysis to decide on what features are important or not. Now, there are two major methods. We have the part that makes use of statistical measures, just like linear regression. You can make use of that to identify features that are relevant to us and those that are not relevant. Now, this one requires some hypothesis testing and all of that. And then we have the other guy that uses the machine learning guy that we're working for to tell us, okay, oh, I just ran through your code. I think these features and these features will be important, so you can make use of them. So in that case, we call that one embedded method. It's basically just machine learning algorithm trying to do a prediction on your data and then telling you that these were the features that it concentrated more on, right? So again, we're going to look at that down. But before we go down, I want to know if there's any question because I want everybody to be carried along. No matter how basic your question is, please let me know because I want that after you leave here, this knowledge will not depart from you. So, any questions? Is there a hand or a question? Yeah, Shola, please go ahead.
I wanted to clarify what an algorithm is.
Oh, okay. So I'm going to explain that in details next week, yeah. But because that's under machine learning. But let me just give a basic explanation. So algorithm is just like in coding, we have algorithms. But in the case of machine learning, the algorithm is just formula. They're just mathematical formulas that helps to find relationship between um, columns between features. All right. So we have like the popular formula of mx plus c, which is slope, and then we have sorry, this could have been a handwritten, but I'm going to have like a proper whiteboard next week so that you can be seeing the formulas and everything. But basically, algorithm is just like a mathematical formulas that the machine learning model uses to find relationship between features in the data set. Does that help to give a bit of clarity?
Yes.
All right. So, okay. So now let's go back to our data set. Remember, this was what we saw. This is our data set. This is what we're working with. So I'm going to just collapse this. Sorry. So that's now if you look at this data, you would agree with me that we have three numerical features. We have the tenor, right? We have the monthly charges, then we have the total charges. The rest are categorical, and then this is not relevant to us, so we have to drop them, right? But we'll do that later on. So now but when we do data.describe, what does this guy do? Data.describe just basically returns by default the numerical values, the statistics of only the numerical values by default, except if you specify that you want it to return for all all the features, which is oftentimes not usually doesn't really give much insight. But now we are looking at the the numerical values. But you'd agree with me that the total charges column is missing here, right? And that suggests that the data is of the object data type, right? So if you do data into the column that is of interest to you, like this guy, the total charges, and then do the type, it tells you the type of the data type of the column. Now, if it returns object, it means that it is a string, right? But it looks like an integer. It looks like a float here. So probably we have an issue. So then the next thing now is to convert this guy to float so that it can become a number like this monthly charges. When I ran this guy, I had an error. So it showed me that there is a string here. It showed me that it could not convert string to floats. That means some rows in this column is filled with this, which they could have respected themselves to fill with empty so that we can just see that we have empty values. That means to do that clean ourselves. This was the only cleaning that I did in this work, right? So all I needed to do was just replace this guy with 9, right? So that it's easy for me to now do is now dot sum, and I can see that we have 11 null values, all right? And then I went ahead to just drop all the 11 for simplicity's sake, because this project is about feature engineering, and again, you're just 11 rules. So I dropped them, and then I'm now able to convert to floats. And if I do describe, I can now see this guy. So any so using you need to trying to scroll back up, you need to see any code, anything.
Yeah, sorry, Sharon. I don't understand why we are dropping the column. I'm sorry, the yes, the columns. Why are we dropping them?
Okay, so now remember that what we even dropped was even the empty rows, not columns, right? But let me take that again, right? Now, do you agree with me that this total charges guy should have been a float, not a string? This total charges column. Do you agree?
Yes, yes.
Okay. Now, I also mentioned that whenever you run data to describe, the goal of this is that I want to see the statistical distribution or statistical information of all the numerical columns in my data. Now, as per we have only as per we have one, okay, we have the senior citizen guy, 1, 2, 3, 4. We have 4 numerical columns here, right? But if you look at this, it's only 3 that it was returning. 1, 2, 3. It did not return the total charges column, right? Now, that means that there is a problem with this total charges column. Probably this data.describe is not saying it as a float. That's why it skips it. So the next thing is now to even check, investigate yourself, what could be the problem. So if you do the type, it reveals that data type of this column is an object. When you see object, it means that it is a string. It sees it as the way it's seeing these other string columns, like all these columns that have words in them. They have letters and not just numbers. All right. So now what we need to do now, we need to clean that data because this column is meant to be a float and not a string. You know that the float type is a normal numerical data type, right? So now, when I do this normally, which is a normal thing to do to convert to floats, it's returned an error. The error is telling us that value error could not convert string to float because what this guy is doing is that it's checking every row in this column. Sorry, I think I should reconnect and then run this code so that I can show you something. 10 minutes, please. Okay, so we have our code now. So now, if I run this guy, right, what this dot as type is meant to do is that it's meant to check for each row. Remember, this is a row in this column. It's just converting each row to the float type. But then it came across a particular row that had just this value. It looked like this. Considering that this is not a number, it could not carry out this operation of converting to a float and then the error message, right? So now it's suggesting to us that that means we have a string in between this data. So what we need to do now is to replace this guy with np.nan. np.nan will give us null values so that it's easy for us to know that, okay, since this is even string, an empty string, probably the person that input this data put um wanted to put what do you call it, a null value, right? But decided to just put an empty string. So we're only taking out anywhere there is an empty string, replace it with nan so that we can have null values. All right. Because if we don't even do that, if we do our normal data dot isna dot sum, remember how we did this up? This was meant to tell us all the number of null values we have in each column. But it did not tell us because instead of this guy being empty, it was filled with just empty string. You get? So now what we did here was replace, right? By the time we do that, we can now see that we have 11 null rows, 11 empty rows in this column called data charges. So now, again, what I now did there was, ideally, there are different steps to handle what do you call it, handle null values. One is that we could just fill it. Okay, sorry, let me be sure. Have you guys done handling missing values before?
Hiya. Hi, Sharon.
Yeah.
Yeah, don't mind me. Could take a 15 minutes break. Like, how do I put it? So it's 45 minutes class, 15 minutes break, 45 minutes class, 15 minutes break.
Oh,
You
okay,
don't get
awesome. All right.
exhausted. Thank you.
Okay, then no problem. Thank you.
The thing of removing um what's it called, columns or features that are not needed.
Mm-hmm.
um I think so far that's all. Okay, then before we left, we were talking about trying to remember the exact thing. Okay, so I
We're
asked
trying
a
to see.
question,
Yeah.
yeah, about why are we deleting the particular, why are we removing some rows, some um is it like some not rows,
Yeah,
it's,
after a while we remove a row, a
yeah,
column, sorry.
a column, yeah. And we talked about that, and you explained that it's appearing as a string, not a float. So it's basically seeing it as like a letter instead of a numeric figure. So we talked about that, and we were in the process of trying to um should I say clean it up, like trying to change the data from string to float, so that we are able to um so we are able to like clean the data, and basically we are able to like remove null values, yeah. So that was where we stopped. Thank you.
Like also, please can everyone just clap for Adiola? Just drop an emoji. Clap, 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 clap. This was great. Yeah. I love these claps. Okay, so now I was asking, have you guys done anything on data filling like handling null values? But I want to carry every sentence. So have you? If you have, yes, awesome. If you've not, then we can just look at it a bit. Can anyone just help me with that answer? Okay, Shola, you are, but did you learn it or it's a personal knowledge? Was it taught?
I think it's personal knowledge. But I think Faith still touched on it in one of her
Personal
classes.
knowledge. Okay, all right then. So let me. Okay, all right. So let me touch on it again then, so that you don't get confused. Oh, sorry, I was talking to myself. Yeah, so as you can see my screen now, right? So let's get back to where we stopped. All right. So I was talking about. So I'm going to digress just a little, right, to the part of um, handling null values. So sometimes in your data set, it's not usually as clean as this guy, right? Sometimes we have, um, so what's the null value? A null value is a value that does not have value. Okay, so a null value is when we have rows that are literally empty. They don't contain anything at all. They don't provide any information, right? So sometimes what happens is that maybe the person that was providing that information did not provide it at that time. Or maybe if you look at Google form, for example, I believe that everybody has filled a Google form before. There are some questions that are compulsory to answer. There are some that are not compulsory to answer. Now, some people may not fill the ones that are optional. So therefore, we would have null values in those cases because there was no response, there was no data for that particular field, for that particular cell. It was an Excel sheet. That cell will be empty. All right. So that's a null value basically. I'm not sure I gave you a definition, but that's the explanation, right? So now in your machine learning work or even data analysis, right? You would you would oftentimes come across issues like that. The question now is that how do you handle a scenario like that? What do you do? Right. So there are different things that you can do. For example, let's assume that it's a Google form. I'm asking a question whether a feedback on this class. If you guys liked this class, everybody said yes. So the compulsory question. Then there was now an optional question. Will you like this class to happen again? So it was an optional. And then majority of people that responded said yes. But most people did not respond. Or maybe just two people said no, and then the remaining did not respond. And let's assume that later on, I'm working on that data. And it was actually important to me to even know the number of people that even wanted me to come back. Maybe I wanted to build a model to predict the attentiveness of students in class, whether the students be attentive or not, based on their responses to the previous forms I've been giving out to people. And then I realized that maybe it's even important to even know people that even said that they would like this class to happen again. Perhaps that could even be an important feature, right? Maybe if you had said no, it could have meant that you're not interested. All right. So now I now see that problem, and then it's important. Sorry, that's a horrible example, but let's just assume it's a valid example, right? So now assume that okay, I want to now handle this column that has no values. What do I do? Now there's different options. There's a case whereby I could look at on an average, what are people's responses? If most people are saying yes, then there are chances that the other people could have said yes. Right, that's one option. I can just fill it with the common value in that column, right? But now I'm going to explain further. Again, I wish I had my writing tab here for a whiteboard, but let's just improvise, right? Now, if we have categorical columns, right? We know that we can easily get the mood. Everybody knows what a mood is, right? A mood is like the most frequent occurrence right? Now, with that mood, we can just fill that column with the mood. Simple. But now, if we're looking at a numerical column, it's a bit more different because can offer us a numerical column can offer us a mood. It can also offer us the mean value. It can also give us the median. Am I right? Any objections to what I've said so far? No. Okay. So now, if we have the mode, mean, and median, we have three options. That means we can use any of these to fill in our null value. Alright. Now, so I want everyone to pay attention closely because we don't have anything to write, so you might easily miss out the points, right? So now, if you get confused, please draw me back and ask a question. So now, in a numerical case, the mode is the most frequent number, the number that dominates that column, right? This is even more easily found in integers, but in floats, it might not be easy to find a value that repeats itself, you get, but there could be. Now, then we have the mean. The mean is the average value in that column. If people are between the ages of 20, 30, 40, right, what's the average age, right? That's basically the mean. Median now is what's the middle value. If we arrange all those values, if we sort them in ascending or descending order, what's the middle value? Let's assume the ages are ranging from 2 to 40. So we can start arranging them 2, 3, 4, what's the middle age that we're going to get? That's what median means. So now there is this thing about detecting outliers or issues with your data. Let me now take you down to the purpose of this describe. This describe reviews statistical issues that might be happening in your data set, in your numerical data set. For example, if you look at this guy, the mean here is 32, right? The median usually the 50th percentile. That's this one represented as 50. Remember that is the middle value. So the value here is what 29. Now 29 and 32 are actually close, so we can assume that this data does not have outliers, is within range. But there are some data sets you're going to see that the median here could be like 29 and then the mean could be 50. And that tells you that you have values that are very high, which are influencing the mean of that column. Imagine you have 2 to 40 and then one person is now 100 years or 120 years. By the time you take the average, it's now that 120 is going to affect the average of that column. We're not going to have value that maybe our average can now be 70 something. Whereas ideally, we had kicked off that guy that had 120, but I'm having an average of 40 something or 30 something, right? So this mean and median values reveal if they're outliers, and then it's up to you to now find out what value is causing the outlier by using data visualization, right? So data visualization helps us to see because data visualization will reveal all the data points, right? So you can now see that okay, this is what is causing the problem, and then you can just drop that value. All right. So now so again data null value, handling of null values is basically you making that decision. If you have a situation whereby the mean and the median are really like wide, they are really different, right? You could just opt for the median to be on the safer side. But if the values are within range, then you can comfortably go for the mean. Now, let me show you how the code looks like. Let's assume that we want to fill this total charges with the mean. Please, does everyone understand up to this point how we got to this point? I want to be sure that everyone understood. Remember that we tried to convert this guy that is numerical to float, and then we had an error, right? And then we realized that there was this string that was here, and then we're converting the string to a null value, right? So it's easy for us to now process further. So as we've done this part, right, we've seen that there are 11 rows in this column that are null values. The question now is, how do we handle this null value? How do we handle it? Number one option is that fill, you can fill with what? With either your main or your what? Median, because this is a numerical column, alright? Number two is that you can just drop it. You can just drop all the empty rows, right? Number four is that you can decide on the value to just put there to replace the nan with, you can use 0, you can use 1. It depends on the reason. There could be sometimes there are actually valid reasons for null value, so it could guide your decisions on doing this. Please, again, am I confusing anybody? Let me know if you have questions. Remember that nan is the same thing as saying no. They're just the same thing, right? So let me know if there's any question. If you understood me, please feel free to unmute so I can proceed. Okay, Opai, please raise your hand. Please unmute your mic.
Yeah, good morning.
Yeah, good morning.
Yeah, please, I want to ask in filling the non-fallow, is it
Mm-hmm.
preferable to use mean or median to fill it?
Oh,
Because
okay,
there
so
was a
like I
time
was.
I was talking to
Mm-hmm.
someone, the person
Mm-hmm.
said it's better to use median instead of mean. So I want a good clarification for that.
Okay, so let me take that again, right? So when I was looking at, so you remember what this table is about, right? It shows the statistical information of your numerical features. Now we have a case whereby a numerical feature is having um we're seeing the mean, we're seeing the standard deviation, we're seeing the minimum value, we're seeing the 25th percentile, right? That's like the first 25 parts of the data set, right? We are seeing the 50th, that's the middle point, which is the median. We're seeing the 75th percentile, we're seeing the maximum value. All right. So now the question now is that we have a data. Let's assume that we have null value in this tenor column. So decide on whether to use your median, that is this 50th percentile guy, or to use your mean. What you need to do is look at the difference between your median and your mean. If there is a similar range of values, then you can go for your mean. But if the values are sparse, for example, if this guy is 29, I was giving an example of outliers, usually the problem. If this guy is 29 and your mean is now 150, then there's an obvious issue, right? So in that case, it's safest and ideal for you to just opt for your median, sorry, right? So just go for the median value. Okay. So now again, if the values are within range, you can go for your mean. But if the values are wide gap, go for your median and then look at how you can treat these outliers. And that's where data visualization comes in. At the time you visualize the values of this tenor, for example, if you do, I believe you're familiar with Seaborn. If you do SNS dot let's say this plot, right? And then do tenor. I think our data is tenor. To show you the distribution of the data set, you can see, right? So now we can see now that we have, I mean, the data actually makes sense. But there are some cases whereby you would see very tiny values somewhere else, and that shows that there's an outlier. What you need to do is just to kick out that value. Unfortunately, this data does not really have outliers, so I may not be able to like, depict that. But if you see it, if you see it, you're going to know. But let's also try a scatter plot. I see now everything is together. But if they have outliers, there'll be some points, maybe all of these data points may just be between 0 and 30. you now see just 1 point hanging on 70, right? That shows that there's an outlier because it's going to affect the mean of the data set, right? So in that case, you might just drop the row that has 70 as the tenor value and work with the rest. Does it make sense? Does it answer your question, okay?
Yes, thank you.
All right, thank you very much. So now I'm going to go down here, right? And for lecture sake, if you want to drop all the empty rows, what you need to do is just drop now, right? In fact, this drop now drops all empty values in the entire data set, right? Our own case is 11, so it's very important to know when to use this, right? So this is one method. Another method is to fill now instead of drop and now filling now, fill now, right? Now we're filling now with this with the median. Okay, let's use a mean. We're filling now. Oh, sorry, I'm just mixing things up. Okay, so now we want to even handle the null values here in total charges, right? I was even looking at tenor. We want to handle the null values in these total charges, right? Now remember that this is where we are, so we don't even know what the value distribution looks like. What we can easily do is that we can just easily do a plot. This plot that we did here, we should have done it for these total charges instead. So I'll just copy here and come and paste here, right? So total charges is this. You can see, or could I also use a distribution plot, right? So I'm not sure why it's taking time to run, but remember that it's scatter plot and plotting. Yeah, so let's see the outcome. Okay. Alright, so the way that is running, right? A simpler way we could just do it is we can use our Python code. Python has the solutions to all problems. We could just simply do this guy dot mean, and Python will tell us what the mean value is. We don't need to stress, you see. So by the time you run this guy, I'm going to interrupt this so that we don't spend too much time, right? So by the time we run this guy dot mean, Python tells us what's okay. Okay, there's a problem here. The problem is that I need to. Okay, sorry. Okay, yeah. So, sorry, I just got distracted a bit. Yeah. So sorry, we're here, right? So we ran this, right, and I'm not exactly sure what's going on. So the problem now is that we needed to fill this with null value, right? And we have this as 11, right? Then the next thing is that we need to convert it to a float first so that we can even get the mean, right? So this data cleaning should even come down after I've changed the data to float before doing all of this. Because this, remember that I said that this is applicable to um, numerical values and not to string, right? So remember that this data type is still an object, So we need to run this first to convert to a float before we can be able to apply any of this mean and median ish to it. All right. So now if we run this, yeah. So this reveals the mean value, which is 2283, and then we can see the 50% is actually sparse. So now this answers our last question. So in this case, our first question, sorry. In this case now, it's ideal for us to make use of the 50th percentile, which is the median value, rather than making use of the mean. Okay. So now what we are going to do now is simple code. We just write data into the column that wants to fill, which is this guy, right? Is equals to, you paste again, right? Now what we are doing now is that we want to fill the null value, fill now, right? With what? We want to fill it with the main value, which is this. Does it make sense? So alternatively, we could even just run this code elsewhere to even see the mean value. Sorry, we said we are using median, not mean. So we can just do median, right? And we see the output, which is this, and which is the same thing that was written here. So either you copy this, or you just run this, or you just put this guy here, and then it does the job. So anyone is going to work. All right. So this is representing this value. All right. Does it make any sense? Is it clear? I don't know. I hope I didn't confuse anybody. Please just let me know that I carried everybody along.
It's clear.
It's clear, right? Okay,
It's
great.
clear.
All right, thank you so much. All right, so now we are filling this guy with the median, and if we run this again, remember that we have 11 rows here. So if we run this again down here, you see that it is now going to be 0. So let's run and see. I see now. So we have filled these null values with the median value. Again, if the mean and the median values were close, we could have just used this mean value. In that case, you use mean instead of median. Alright, so it's just decisions that you make as a data scientist. So now we have this guy clean. We have our data clean. Does someone have a question? Adiola, please go ahead.
Okay, yeah, Sharon. I was just about to say that this column has outliers, right? That's why we are using um the median value.
Yeah, most likely it should. But now let's see. It might not have. It could be that the values actually now there's a thing of outliers. Outliers are maybe we have group of values that decided to be off points, right? And sometimes we have a lot of values. Probably we have like two groups of values, right? We have like lower values and upper values. Not necessarily that they're outliers, right? But because we have upper values. So in that case, by the time we calculate the mean of the upper and lower values, then it affects the mean value and does not affect the median. So I have a question again. Yeah, Onyeka.
Yeah, yeah. Concerning this me and media conversation, it's very safer to use media, like what Sharon has said, because you can't always totally have outlier. So just like if you use the media and there's no outlier, you still give it the same result as the mean to a very large extent. But if you use the mean and you have outliers, you have like a very wrong value. So most times, based on what I've been advised and what I've seen so far, using the media is usually safer because it covers for both scenarios. If you understand what I mean, Sheila.
Yeah, I agree with Onyeka. Yeah, so it's actually the safest part to just fall on there. You can never go wrong with the median guy. It's a cool guy. All right, so yeah, so I think that's that about that in terms of handling null values. All right. Again, if you don't want to use any of this guy, I want to just use 0, just put 0. So you're filling all null values with 0, and that's it. So now let's proceed. And the next thing is that we want to now look at the feature engineering goal. Right. So I think I'm going to start from here, feature engineering. I told you that there are three different types. I'm going to do a recap so you don't forget. There are So now there are three different types. I mentioned the okay, not sure where I wrote that down. I think we looked at it. That was up, right? The feature selection, the okay, I'm not exactly sure where they are. But now there are three different types I mentioned earlier. We have the feature selection, we have the that feature selection is now where we are selecting features. We have the one where we are trying to derive a feature, right? And okay, this is strange. Sorry, let me just go back again. If I'm not mistaken, deleted that. Okay, yeah, types of yeah, this is it. So I mentioned that there are three types: the feature creation, right? The feature transformation, and then the feature selection. Feature creation is that we are trying to derive a new feature from the existing features. So that's going to be the first one we're going to look at, right? And then we'll try the second one and the third one. So let's keep going. So now the first guy here now is telling us that hey, you can do something with us. So we have monthly charges, we have total charges, right? They're not exactly the same. Now, monthly charges is how much we charge this customer per month. Total is how much we've collected from this customer, right? Now, if we look at the data distribution of these two guys, this one is for the monthly charges, this one is for the total charges. So now you can see that they don't have the same distribution. That means it's not exactly, they don't have like a rule that says that the higher my monthly charges, the higher my total charges. That's what I mean by data distribution, right? So what we can do now is that we can just create a new column called average charges that just divides this guy by this guy. Then we can now drop these two columns and work with this one. All right. So now, but before then, there's a thing called correlation. Correlation is how related am I to you? Like how you know how related are we? If we were of closer relation, right? The correlation I have with my sister is different from the correlation I have with a colleague, right? Because we have more closer entity. So now the correlation between two variables tells us how much the higher this one is, the higher this other one is, or the higher this one is, the lower this other one is. So there is something going on between the both of them, right? So now in that case, normally in your machine learning projects, it doesn't make sense having two columns that are correlated, feeding that those columns into your machine learning. It's just like duplicating value. Because we already know that once we have high value of this, so we always have low value of this. So there is no point wasting energy duplicating those two columns and feeding into the model. We just have to pick one. Or you can generate one new feature from those two and then drop those two columns. Does it make sense? I believe so. All right. So now what we are doing here now is that we are generating average charges and then we're going to delete these two columns. They will no longer be in our data. We're now going to have average column. All right. So now the formula here is that total charges divided by monthly charges. There is no formula anywhere. Oh, this is just based on your own experience as data scientist. You just make those choices yourself. Should I? There's no rule that says that you must always do this, but I mean, there's where you see data, you know that I should do this, right? So now, if you look at these two guys, their correlation is 5%, and that means they have some level of relationship, although not the same data distribution, but there's a relationship between both of them because total charges was calculated from monthly charges, right? So now what we can do is just get average charges and then we drop these two guys. So when we do that, this is the formula, the code for dropping columns. Just do data dot drop the columns that you want to drop. You list all of them. If it's just one column, just put the one column inside these brackets, these square brackets. If it's two, you separate by comma. If it's three, continuously, just keep separating by comma. All right. Now you can see the new shape of our data. Initially we had 21 columns. Now we have 20 columns. Who can tell me why we have 20 columns and then before we have 21 but now we have 20? Who can tell me why?
because we now delete we removed we made monthly charges and total charges one column, so that's we are short of one column now.
Yeah, but don't say we made it one column. Making it one column look like maybe we merged them,
Oh, okay,
right? So
we
now we
calculated the
created a new.
average. Yes.
Exactly,
Okay.
exactly. So now that's the answer. Thank you so much. So now, if we plot this guy, we can now see that the distribution of these average charges is slightly different from these two guys. Yeah. So like we now have a new data set. This is what we call a derived data. Like we are getting derived, like we're getting a data from somewhere. Right. So now, the next thing that we spoke about was feature transformation. If we go back here again, we can see that we mentioned feature transformation, right, which are of two types. We have the data normalization, which means that we can compress the range of values to be either, there are two types, normalization and standardization. So let me explain down, and then we'll also look at the encoding method. So now we have the, let me get, so yeah, so now this is data normalization, and then we explain the two types, which is normalization and standardization. When we talk about normal means that we don't want any abnormal, sparse looking values, right? We want values that are contained, that are within a certain range, right? Right, not necessarily deriving a normal distribution as a dumbbell shape, not exactly, right? But now the goal is that we want, for example, our normalization method should return range of values to be within either 0 to 1 or -1 to 1. What I mean by this is that if you're looking at these average charges that are ranging from 0 to 80, when we normalize it, the the minimum value will be 0, the maximum value will be 1. So I'm going to compress all of this to fall within that range. All right. Now, there is this other method that is called standardization. This one uses the mean and standard deviation. If we look at, when we're looking at mean and standard deviation here, you can see that the mean of total charges was 228. Standard deviation was 226. So now in our case, we are going to now compress these values such as the mean will now be 0 and then standard deviation will be 1. If we do this, then we say we are standardizing, right? So now, um, so this are like these two methods. Now the question is, how do I know when to use which one? Normalization is mostly used when kind of feel like you just need to like compress your values. I think that's like the basic way to explain. But standardization is mostly used when your data set is on normal distribution. When I mean like it's looking like this, like the way this dumbbell, that bell we used to use in secondary school. I hope everybody saw that bell, that golden bell, right? When you place it down, it gives that curve down, right? So that's what we call like a dumbbell, like, we are trying to so we have a data that looks like that, something similar to this guy, right? So we have a data that looks like that, then it's easy for us to just use the standardization format because we're now trying to ensure that the mean is actually 0 and standard deviation is 1. So actually now creating a normal distribution. Where we have like a normal data set like this guy, we can just adopt normalization technique. All right. So now these are the formulas. Normalization is basically for each for each value in your for each value in your column. For example, for this average charges, for each value here, say 10, right? What you do is 10 minus the minimum value in this average column, which could be 0, let's assume, all over the maximum value, which could be 80, minus the minimum value. That will give us the normalization. Standardization is the same thing, but instead of using this max, we now do all over the standard deviation of the column, which is average charges, right? So now let's try an example. if you want to do standardization, this is the code here. Remember that I said it is mean. Oh, this should have been the minimum value, which is MIN, right? All over the standard deviation. This is for standardization. But then we decided to opt for the normalization technique, right? Which is this. Now the formula is the value, which is this guy, as every value there, minus the minimum value here, divided by the maximum minus the minimum, right? So now when we calculate this, we're now replacing these new values with that same column name. You could choose to create a new column name. All you need to do is just to give this a different name, all right? So that it does not overwrite this former name. But for me, I want to overwrite it, all right? So we are good to go. Now, again, the goal of normalization and standardization is the same. It's just to compress values within a certain range, all right? Now, if you run this guy, you are going to get, oh, I didn't run this guy up here, sorry. Okay, so if you run this now, you're going to see you're going to see now that the values are now compressed. Are you seeing? Before we had 10, 20, and all of that, right? Now, if you run your minimum and maximum, you see that the minimum value here is 0 and the maximum is 1. This is what we call normalization. Okay. So, is there any question on this normalization before we go into encoding? Any question?
Sorry, Sharon, for the formula, we can.
Mm-hmm.
Oh, is there like, what's the name of the formula, please? Is it just standard? Did you call it standard deviation or something?
So this one up here is standardization.
Okay,
This one down
standard.
here is normalization. So because we're making use of normalization, this is one we are running. I commented this one, so it will not run. It's just a comment. If you want to
Okay.
convert it to a code, just remove this slash. I say now it's
Yes.
colored. If I
Yes.
put back the slash now, it's like a text. It will not
Okay.
run. You get. So this is what we are using for normalization. Right. So if we were to be standardization, if we had used this one up, by the time we run it, if we check the mean and standard deviation, you are going to be 0 and 1. All right. So I hope that is clear. Shala, yeah, go ahead.
Yes.
Is there a way um to use that formula without actually writing that long thing?
Yeah, there's a way. So we have sklearn library for that. From sklearn dot, I think, pre-processing, right? Import for standardization, you do standard scalar, right? This guy, and then for normalization, I think it's normal. I can't remember, but I think it's normal or something. Normalization. I can't remember the library name, but
It's
in the
min
case, I
max,
think it's
max scalar,
main marks, right?
min
Yeah, look at
scalar.
me. Main scalar. Uh-huh. Yeah. So now let's assume we want to use this standard scalar, for example. All you need to do is you can call it scale or something, right? And then you initialize it. Initializing mean you're just calling just where you call it, like you define a function. So I just redefining this library, like it should come to life, right? So now the next thing is now us applying this guy to our data set. So now we can now say, we can just call, let me just put it as D, but you can assign it to a column name. We can say data into, let me just name, right? Is equals to scalar dot fit underscore transform, yeah. Then now put the data that you want it to fit, which is this guy. But now once I'm a scalar is that it requires that to the in a series, it might give you an error. So just simple, just put double square brackets instead of a single square bracket, and then we are good to go. So now if we run our data, Um, we run our data. You'll see. I see now. So this one was for our standardization method, right? The first one was for normalization formula. So the same thing for the mean max guy. The same thing. Replace with this guy, right? We can call this one no, right? And then if you run again, I saying the result I was getting from my normalization with this long formula, the same results that this min max guy gave me. Can you guys see? So whichever method you prefer, it can work. So you can use this one or you can use this one. But this is the formula in writing. Alright, does that answer your question, Shola?
Yes, it does. Thanks.
Okay, thank you too. Alright, so now I think we are 1 minute to our break, Abby. So let me just pause and then when we come back, we'll go into encoding.
All right, thank you so much.
Alright, thanks for the clap. Thank you. Easy peasy stuff so far. Okay, I guess we're good to go. Yeah, so now we have this guy here. Where did we stop? So we stopped at this place when we're looking at this normalization and standardization, right? Now we are going to the other part of encoder, and I'll keep this part very simple so I don't get confused. Now, like I said before, encoding is all those your categorical columns to numbers, right? There are two ways of doing it. In fact, there are three. But now, for simplicity, there are two ways: label encoder and one hot encoder. Now, what's the difference? Label encoder, what it does is very simple. Like now we are saying yes, no. Maybe we says no because no is n is like we are arranging, we are sorting this in alphabetical order. No will come first. So no could be zero and yes we want. That's all. But now what one hot encoder does is that let's assume this column is only no and yes that can that the possible values. Instead of encoding 0 and 1, what to do is that it's not create new columns. So we have online backup underscore no. We now have another column called online backup underscore yes. So in a case whereby this like this row now, the value was actually yes. So for online backup underscore no, the value will be 0. For online backup underscore yes, the value will be 1. And then it goes like that. So now one hot encoder is good if you're trying to like avoid bias in your data. Maybe you want a situation whereby you have a nominal data that does not have it's not it does not have class or level like grade. We have ABC, right? Now ABC can comfortably go with label encoder because A is greater than B. When in case where we're looking at tribe, we're looking at some things like that, it's better to use the one hot encoder because it balances out. So no one is one, no one is two, no one is three, right? And then the model cannot feel like since three is greater than zero, three is of higher value than zero. You get. But now, in this work, we won't be looking at one hot encoder. We'll only be working with label encoder, right? Label encoder is straightforward, and again, is that the categories we're having here are not categories that require. You only have the bias thing, except the gender that one could talk about. But then, gender is just two. In this case, you have 0 and 1, so it's not really a heavy problem in this case. So we're just going to work with the label encoder. But now another thing I want to make mention of is that in machine learning, it's very important that you remember the goal of machine learning is to make a probability that in this problem is that can we make a probability whether this customer will leave us or not. Now we have built our model. Let's assume we have the model, right? So we'll explain that next week. Now, how do you evaluate the performance of this model? You need to be sure this model is performing well, right? You try it out on another sample of the data that you people have in your company, and be sure that it's working well before you now go and present it and say, okay, I have a model. All right. Now, to avoid data leakage is when your test data contains values that your model has already learned with. If that happens, that defeated the purpose because your model already knows the answer, so you're more or less not even evaluating anything. Well, I'll go in details next week. So just assume that what we are doing here is simply just splitting data into two parts. 80% of the data is going here, 20% is going here. All right. So now, again, just assume now that we have two parts of our data frame. We have the train data frame and the test data frame. We'll explain this in details next week. I mentioned that we're going to draw customer ID because it's irrelevant. Now, this is where the main work starts from. Now, a simple way of encoding things is just to use dot replace. Replace no as zero, replace yes as one, right? So it's simple. Anywhere it says no, put zero. Anywhere it says yes, put that, right? Now, another way we can even do this is use the label encoder function, which we can import from here. See it's here. From sklearn preprocessing, import label encoder. The same way we did for the standard scalar. All right. So now, what this guy is doing is that it is encoding. I'm going to have this code next week again, so I explain it in details. Again, don't stress. But just know that what label encoder is doing is that it's converting all the categories to numbers. All right. Now I want to explain this part. This is where I want us to really focus on here. Now here is feature selection, the third part, where we are trying to now select what are the features that are now important to us. There are two major or three ways. Let's say, yeah, there are three major ways of doing this. Number one is using the linear regression, the ordinary least square method, right? Number two is using the feature selection methods. They have libraries for feature selection, which makes our life easy. And number three is now using a proper machine learning model to identify the features that the model used to learn and then just pick up from there. So now let's take them slowly. The first guy, the ordinary least square method, is just a statistical approach. Some people might be familiar with this already. That's awesome. But if you are not, let me explain. What this is doing is that it has something called p-value, right? We already have the code for it. Here's the code here. If it returns a p-value that is above 0.05, right? That's what we're meant to be focused on. Once you see the p-value, just check, is this an above or below 0.05? There is something that is going to, like, there's a decision that's attached to that. Now, in statistics, right, we have this thing called hypothesis. That's the initial assumption that you make. It's called the null hypothesis. That's initial assumption. Oftentimes, usually toward the negative side, right? Now, the assumption here is that, remember that the goal of this is we want to find out what columns are relevant in terms of predicting churn or not churn, right? Now, the null hypothesis is trying to tell us that there is no column that is relevant, right? But the alternative hypothesis telling us is a lie. There's definitely a relationship between this column and the target variable. Now, how do we judge? To judge the case, if your p-value is below 0.05, we reject this hypothesis. If your p-value is above 0.05, we accept. All right. So now, in this case, the goal is that we want to find out all columns where their p-value is below 0.05. That means they have a relationship with the target variable. Is that clear? Is it confusing? Okay, I think as a no. So now, this is the code. All you need to do is just to put your label column, which remember that we'll define here, but I'll explain this in details next week. That's just that chunk column, basically. That's what is here. And then train X is the remaining of the columns. All right. Now just do sm.ols dot fit the summary, and it's print out this guy. Now, if you look at these results, this column, this P, whatever, is what we are focusing on, right? Now, for gender, gender is actually below 0.05. So we can assume that it is relevant, right? Senior citizen is below 0.05. We just keep checking like that and pick out all the columns that are this one. Device protection is above 0.05. So we are going to throw it away. We are not going to use it. All right. So we pick out the ones that are important, and that's one approach. Another approach is using existing libraries called, we have one like select kbase. We also have this PCA, right? So although there are arguments on when PCA outperforms escape select kbase and when select kbase outperforms PCA, PCA is in a topic altogether on its own. But for simplicity, we can go with select kbase. This also works very fine. This is from um, sklearn as well. So this is where I imported it here. This is it from sklearn feature selection. Import select k best. So you need to provide the k value, which is the number of columns that you want, and then it tells us the top 8 columns that are important. I was one that provided 8. You could do 12, you could do 4, and then see what you're going to get. All right. So again, we would properly look into this because these are where we are now actually picking our columns for our model building. All right. So now these are the 8 stock columns that it tells us are more important. All right. You could see that there are columns that are here, right? So maybe you could even do a comparison and finally decide on what columns to go for. Okay, now the last guy is, sorry, I hope I'm not rushing too much. Please let me know if there's any question. I'm pausing for a question now. I need at least one question.
I'm good.
Okay, you're good. Okay, awesome. I love that feedback then. All right, so now let's do the option now using an ML model. We can try a random forest, we can try a decision tree, right? Yeah. So now I've explained what a model is, a machine learning model. A model is the outcome of the algorithm learning your data and everything once it's done, it's built a model. So you have a model that you can now any right. Now in our own case, we have a decision tree. Now decision tree is a type of algorithm that can be used for either classification or regression. All right. Next week. Right. So now we have this model, and then we want this model to now learn the patterns that are between these independent variables, which are the main features, versus that shown column, which is our y feature, which is our target column. All right. Now, dot fit means that please learn this relationship. Once it learns this relationship, it builds a model. So now this model is no longer empty, right? Now this model now has values that we can get out of it. We can now ask this model, what were your, like in terms of rating, what features will you say are more important than the other ones? There's a method for that. All you need to do is just dot feature importances, right? Now, this is also a data visualization code. You're going to stress, right? Just plots, and then when we look at this, we can now see that these are the features that were important to this model, right? And then these are the least features. So you can see that average charges, the amounts that I've been charging this customer can determine whether this customer will leave us or go. All right. Will remain with us or leave us. Then we have the contract. Then we have the tenure, how long this customer has been with us. We have the method that the customer is to use to make payments. Maybe this can classify it as actually the tech savvy customer or all of that. Then we have the online security, we have the internet service, we have the gender. So now it's less for you to know what top end features are you looking for. Are we looking at top 5, top 8, top 10, and then we make all those decisions here and know what features that we can now pick up and say, okay, let me now retrain this model with just these 7 features or just these 8 features. Or you can even now create a new model, maybe try another algorithm entirely, maybe random forest or XGBoost or whatever, making use of these features that you've identified were important here. Now, this is just basically what feature engineering is all about. And it also emphasize that it doesn't just end at the point. You can't just say, okay, I've done this, I've picked my features, and then let me build the model. Sometimes it requires going back again to the data, making some changes. For example, you could even come back instead of doing normalization, you can now try standardization, all of those back and forth until you get something good and you're good to go. So yeah, so I think that brings us down to the end of what I have to say. Let me know if there's any question before I take a bow.
If I may ask, what's the difference between random forest and decision trees? Do they
Oh,
give
okay,
similar?
yeah, yeah. There is a similarity and there's a difference. Now, a decision tree, as the name implies, is just a tree. When we have a tree, right? But in this case, we're not talking about the literal tree, like normal tree that I can picture. We are talking about the kind of tree where you have. Let me now draw something the way ChatGPT draws. Where we have something like this, right? And then I can't do this. So we have so imagine a box. Okay, imagine this family tree. That's a perfect example. A family tree, right? You have your great grandfather at the top, all right? Then let's look at the male side of your family tree. We have your great grandfather at the top. Then under him, you now have two or three arrows. Let's assume he had two sons, right? We have Obi and Ade as his two sons. So we have the two arrows down. We have Obi, we have Ade. Now under Obi now had just one son, right? So that's his son's name is Jonathan. So Obi will have one arrow under him called Jonathan. On the other side, Adele may have like two or three, maybe have three sons, three arrows, right? So are you picturing what I'm trying to say now? So this is the kind of way decision tree works. Each one, like when you talk about the grandfather, Obi, Ada, they are the nodes. They call them node. And in the case of machine learning, they are the features, right? So machine learning does something like the if else statement. It first of all find out for the churn, right? Um, did this person have, or like the income was below 50,000, right? Now under below 50,000, the age was between this and that. It does that breakdown kind of downwards. That's what we're calling a tree. Now a random forest is a combination of multiple trees, right? So we have many decision trees like that. Like there are many in one, just the way we have many trees forming a forest. That's where it is now. So all of those, we could have up to 1,000, 2,000. There's a what do you call it? There's an argument in your random forest that defines that. So that's basically the difference between the two of them. So random forest now does like ensembling method of the outcomes of each decision tree, right? And decision trees in your random forest. And out of those 1,000, 700 classifies something as John. It picks up that one as the output. So it's like an ensembling kind of thing. But decision tree is just a single tree. Yeah, so that's the difference between both of them. Who asked that question? Did I answer your question?
Okay, thank you. Yeah.
All right, you're welcome. So, done. And I don't think there's any other question. Is there anyone? I think we have a few minutes before we call it a gathering.
Um, my last question. So, from all
You can
that
even ask me than that one. I'm listening. All right, go ahead.
from all that we've learned today, talking about data processing,
Mm-hmm.
data in data, it means that it's all subjective to what you want to get at the end of the day.
Exactly, exactly. So you might not even follow the exact thing I have here, but this will just to show you things that are possible, things that you can do. It depends on your data. You now make decisions of okay, this is what I need to do, and this is what I don't need to do. All right. So Iman, does that give clarity? That answers the question, right?
Yes, that do. And then
Awesome.
there were times that you imported certain things. So let's say
Mm.
you are trying to process a data, and
No, no.
let's say you are trying to find the maximum, the minimum, and you don't know how to import them. How do you go by them? Like how you don't know where to actually bring the code,
Oh,
or
simple. Don't even stress. See, let me share my screen. Right. One thing is that you don't have to bother yourself about memorizing codes. Right. For example, I want to do standard scalar. I don't even know the code. I just do standardization. Right. Where is it? Standard scalar machine learning. This is a basic search. Right. Okay, there's a problem. Sorry. I'm not sure what's happening. Let me try again. Standard scalar. I'm having an issue here. I'm not really sure. But again, what I'm trying to say is that you just have to Google what you're looking for, and then you would find it. You get. I think I need to just do this. Yeah, yeah. So I googled just this, right, and then I had this output here. So just click it, and then SQLN is nice. They give an example. I see here now. They're showing you how to import it, right? Now you have your own data already, right? So just follow their steps. Remember, I did something like this, and then you fit. So they did fit. I did fit transform. Any of them would work. All right. Does that help?
yes, please. Thank you very much.
All right. Anytime you're stuck, just feel free to Google. It's not a crime. All right. So, Shola, you have a question? Please go ahead.
Yeah. It's not really a question, but more like a request. Can you
Oh,
share your notes?
oh yeah, sure. I'll do that. I'll send it through Onyeka. I'll find out how things are shared. But I'll send it to her definitely. This class is for you guys. I don't need a notebook.
All right, thanks.
All right. You're welcome. So any other thing? No. All right. Onyeka, over to you. I kept the time.
Oh wow! Thank you so much. Thank you so much. Please,
Thank
can
you
we
so
have mute? Can we tell Sharon? Thank you so much.
Thank you so much, Sharon. It has
Very
been an
much.
insightful
We are
session.
grateful. Thank
Thank
you.
you too. I really enjoyed this class. To be honest, I am happy that there were so many questions. There were feedback. There were responses. I did enjoy it. Thank you too.
Yeah, thank you. That's the way we are here. We're very
Yeah,
eager
I
to.
love it.
Yeah.
I love it
Yeah.
for
So
real.
who wants to give vote of thanks? Emmanuel, please can you help us give vote of thanks to Sharon?
Okay, Miss Sharon, on behalf of the class, I want to say most grateful. We thank you for your time. It's not easy. Ms. Onika has been saying all these have been done for free, and we do not take this for granted. So, on behalf of the class, we really appreciate you. We love you, and we say thank you so much for what you've done for us. God bless you.
So
Thank you
much,
too, Emmanuel.
Emmanuel.
God bless
Thank
you
you
and
so
thank you
much, Sharon.
everybody.
We hope to see you next week. We are very grateful. This class, put this
Yeah,
into practice. Let our knowledge not be in vain. Watch our video. And if you get stuck anywhere, put on Slack. If I'm not available to answer, there'll be somebody there that knows that knows the answer to that question. I will be able to give you the appropriate answer. So please have a nice day. Do enjoy your weekend. Cheers, everyone.
Thank you, Onyeka. Bye, everyone.
bye. Yeah, Emmanuel, go ahead.
Yes, I had a question earlier. I wanted you
Okay.
to go through um, the linear regression model again.
Oh, okay. All right. Let me share my screen here. Okay. Think it down here. Okay. So now I was saying that a linear regression model is like the typical linear regression that we know about in terms of the formula for calculating a line where we have wx plus b or mx plus c, right? Now, in our own case, the x is simply the values, right? Like what value do we have for BMI? What value do we have for distance, right? And then the y is the outcome of this equation, right? Now, if following the equation of a line, we want to now find out that if the y given to us is so and so, how far apart is this y from the actual value of y? Because this is our y variable, right? So we have all of this as x, x0, x0, x1, and then this is y. So we want to predict this y using these values of x0 and x1, right? Now, I mentioned that following the formula of wx plus b, what we need to do is this guy becomes based on the number of features that we have in our data sets, the number of independent variables, right? In our case, we have just two. So we're going to have w naught x naught plus w1 x1, right? If you have more features, you keep adding all of them. Yeah, but in our case now I have just two, so I'll take out these ones. Now the thing is that this w naught and w1, we have no power over them. They are simply coefficients, right? Which are introduced by the machine learning algorithm itself. So there are random values that it comes up with initially, and then the more it learns, the more it starts tuning values. So in machine learning, whenever there are parameters, when you have parameters that you cannot change, you have no power over, you cannot change them, right? They are called parameters. Parameters, sorry. And then we have the one called hyperparameters. Now, these ones are values that we have control over. We can use it on our own end to tune how the model or how the algorithm is making its calculations. Now, back to this linear regression, right? Now, what it does is that whenever it does its maths, it checks the resulting value of y, which is like the predicted value, and compares it with the actual value of y. Do you get? Now, whenever it does this, what it's giving us is the error. Now, the goal of machine learning is that it keeps, sorry, it keeps trying all of this. We're looking at the loss graph. It keeps trying all of this to minimize the loss, right? Until it gets to a point where the loss cannot go lower than it is, then at that point, it returns the model to us that it has completed the model. Do you get? So now it's like a loop. It tries, it checks the error, it comes back, it goes back again, it checks the error, and it keeps going until the error value is at the lowest that it can possibly get. It might not be zero, it could be 0.3, which is still high, but if that's the lowest it can get, then that's just the result that the model is going to return to you. Does it make sense now? So now I said that linear regression is purely for a continuous um, task, continuous related prediction, right? What we call a regression task, where we are predicting actual numbers, continuous values. Then we have the logistic regression, which is for categorical task. We are trying to predict categorical values like early or late, right? So now we have 0 and 1. Now the formula for logistic regression is quite similar to linear regression, except that because it's predicting the probability of being 0 and 1, that means this model needs to be probabilistic. It cannot tell you 0. I did draw that graph again. It cannot be 0 or 1, right? So it has to be a probabilistic graph that goes like this. Again, that's what we call a sigmoid function, so that the values can be between 0 and 1, and then we have range of values. It could cut across 0.5. So now we make use of the sigmoid function, and this is the formula: 1 all over 1 plus the unit number raised to power minus x. And we mentioned that this x is basically replacing it with the formula of the equation of a line, which is the formula that we have here for our linear regression. So now when we place it here, right, we end up getting a probabilistic result, right? And also this guy gets the probability, checks if it's predicting that this guy is likely going to come early, that is, has a high probability that to come early, it checks the results. If the result is that the guy is coming late actually, then that means the loss is high. So it goes back again, same loop, until it has a low loss value, whereby the probability of becoming 0 is actually labeled as 0. Right, and then it returns to us our model, right? But sometimes it's really a bad model and there's nothing it can do, right? So we know that it now falls back to us to start maybe improving the data, hyperparameter tuning, start doing some things left and right, and then feedback to the model and see if the model can give us a better result. So that's what machine learning entails. It's like a back and front movement. It doesn't just work once and we conclude, right? So you're going to see the example, okay, in our notebook. It wasn't a straightforward approach either. So there was a little level of back and front before we're able to get a model that's good enough. We're going to see how that works. All right, so Emmanuel, did I answer your question?
Yes, please. And I wanted to ask, when do you, when as maybe a programmer or as a data analyst, when do you feel that the model that you built through machine learning is not working or it's not functioning? Maybe is it based on your expected outcomes, or because let's say you built a model and at the end of the day it's giving you a marginal error of, let me say, -1 or 0, and then let's say you wanted it to predict maybe early, but you, you fed it with both late and early, and then at that point maybe what you were expecting, you wanted early, but you keep on getting late. Is it
Mm.
because of the data set that you fed with the model, or what? I just
Now
want to be
there's
clear on that.
now there's this thing called model debugging, right? The way developers debug their codes, data scientists debug models too sometimes. Now there are some situations whereby you actually need to understand why is this model messing up. Now we have extreme cases whereby it's mostly classifying a particular class, right, or a particular category. Then we could assume that maybe the trained data has more of that category than the other one. That could be one thing. And that leads us back to checking the distribution of early and late in our data set. And then if truly we have more of late than early, maybe it's wise for us to um, I'm going to explain this in a notebook, so nobody should get lost, all right? It's wise for us to do what we call either oversampling or undersampling, whereby we are now reducing the data. For undersampling, we are reducing the data so that the proportion of late and early will be the same. Oversampling is when we are now increasing the data so that we can now have more of early samples so that the proportion of early and late will be the same. Therefore, either method is basically to balance the distribution of the data, the number of early and number of late should be within similar range. But I'm going to give an example because thankfully the data we have is quite a stressful one. So we're going to like do a proper hands-on. And then also, so add to that, we also evaluation metrics that we look at. We also ask questions like what metric is more ideal in this case. We are going to look into all of that. All right. So let me get the code now. I want you guys to pay attention, right? And if you have questions, please again feel free to let me know. So I'm going to start from here. approximately where we stopped the last time, with a bit of more emphasis. But let me just rerun the previous notes code so that I revive this notebook. Um, so we did all of this in the last class last week, and today we'll continue from where we stopped. What we are now doing is that last week we basically did data cleaning and then feature engineering, right? So now this week is for us to now build a model that can predict if a customer is going to churn or not. We have a data size of 7,000 plus and then 20 columns. So we assume that the label column is here. So we're probably having 19 independent variables and one dependent variable, right? And then we are ready to get started. Then we did the data transformation here using normalization technique, and this is the minimum and maximum value, right? So now we also mentioned that this customer ID is irrelevant, so we're just right. So I believe that we're all on the same page now. Nothing else has been done, right? We are good. Okay, now so let's get started into the main thing. So I mentioned that today is going to be focused on supervised ML, again, which is a data that has both the independent and dependent variable. And more specifically, we're focusing on the classification side of things, right? So now, like I mentioned before, there are quite a number of algorithms that you could use for classification tasks. We have the logistic regression, which we have gone through. We have the random forest classifier, which I mentioned last week, that it's a combination of different decision tree. That is called an ensembler. Like it combines a lot of decision trees together in its algorithm, right, to form a single algorithm called the random forest, right? The decision tree is a classifier that kind of like does the whole family tree method of breaking breaking down features into classes. For example, something like this. Um, so yeah, so a decision tree can be like the we have the churn, we have the churn, and we have the not churn, right? And then based on this, it kind of like checks for features. So for the not churn, the average balance is less than 40,000, right? For this one, and then the average balance here, it just keeps breaking down all of that. Maybe the gender, or should I say the tenor, is greater than 5, right? And then so it just keeps breaking it down, right? Then the random forest guide combines multiple of all of this, creates them, like it could be as many as 1,000, 10,000 decision trees, right? And then it checks if this single guide predicts churn and the next guide predicts not churn and the third decision tree predicts churn. It checks how many churns were predicted, how many not churn. If you have more of not churn, it returns the final value as not churn. If you have more of churn, it returns the final value as churn. So while decision tree is a single entity, random forest is a combination of multiple decision trees, and that's why it's called a forest, right? So now, then we have the support vector classifier, which could work for both a linear data set and a non-linear data set, right? So for a linear data set, it tries to check that if we have two clusters here, all these data points are data points of food that churned, all the data points are data points of food that did not churn, right? So it splits it. and then it gets the maximum points. Let us say we have many of these here. It gets the maximum points of this, and then and then the maximum points splits like this. Okay, my hand. Okay, splits like this. Let us do the maximum points here, right? And then it checks for the maximum points of this other guy here, right? And splits on that line too, like this. Pardon me, like this. So this is the maximum, and this is the maximum. When I mean maximum, what I mean is that out of the distribution of the not chunk category and the chunk category, which of the data points are the closest to the next category, right? So this one is at the edge, this one is at the edge. So it draws two lines, right? So what it now does is that for every new data point, it checks how close you are to each of the points, and it helps like group them. So that's just the idea behind support vector meshing for a linear case. But for a non-linear case, it's a bit more advanced, which I would want to go into now. It uses what it's called is it kernel? Yeah, I think kernel. How do you spell it? Kernel. Okay, no, I can't remember. I think yeah, like this kernel, Kernel. Yeah, Kernel. So this is what it uses. So you can look that up, and but let's not dive into all of that so that people don't sleep in this class. Now then we have XGBoost, CastBoost, LineGBM. There are just a lot. But the ideal thing I would recommend is that for anyone you want to use, take out time to just Google them and how it works. There are lots of resources online, and thanks to ChatGPT as well, you can just ask how does the support vector machine classifier work, and it gives you the details, right? So yeah, so now let's get into the code. We've spoken a lot of theories, right? Now we have a real life data set here of customers that churned and did not churn. I want to build a model. This is hands-on. If you got this notebook for the last class, you can feel free to open it. You'd see what I'm saying right now. And then you also have access to the data set. Yeah, so now let's get started. Now we have models that we have people that have done all of these calculations and wrapped them up for us. So we don't need to start doing the manual calculations ourselves. And all of these are hosted on sklearn, right? So for logistic regression, what we need to do is from sklearn.linear model import logistic regression. For decision tree is .tree. For SVC is .svm. For random forest is .ensemble. You know, again, if you're not sure, just Google random forests or yeah, random forest classifier sklearn. And there you go. This is it. So you can just do from sklearn.ensemble import random forest classifier, and you're good to go. All right. So now, next thing I mentioned about is that remember I told you that we need to split the data. People often split 60, 70, 80. It depends on your choice. Now in this case, we chose to go for 80%. That means 20% will be for test. So what we do is test size equals to 0.2. Again, this is a library, right, on sklearn. So just do from sklearn the model selection, import, train the test split. Now the good thing with this is that we can choose the test size that we want to split by, and we can also tell it to shuffle. Remember I spoke about shuffling, right? So shuffling helps us to rearrange our data and make sure that it's evenly distributed, right? Then we have the random state equals to 42, which means that if we repeat this random states value, whenever we rerun this code, the exact way that it was shuffled before, the exact way is going to be shuffled again, right? So if you want to maintain consistency, it's good to choose a random states value and stick to that number that you've selected. If you change the number, it's going to change. If you don't choose this, it will always be a random shuffling each time you rerun the code. All right. Now, because we shuffle the data sets, we have to reset the index because let me run this code first. and then run this code. Now, because we shuffle it data, if we do tests, for example, the head, you can see now that the index numbers are shuffled, right? They are scattered. So we want to reset things to normal. What we just do is reset index. This is not part of machine learning, but it's just a good thing to do. Alright, so now if we run test the head, you can see that it's now more organized. So we can see now it's now 0, 1, 2, 3, 4. Please, does anyone have a question? Okay, that's a no. Alright, so now next thing is that we want to replace our churn. Wherever we see a no, change it to 0. Wherever we see a yes, change it to 1. Remember that computers don't understand English. So we are going to convert all of this into codes, right, into numbers. That's where we introduce the label encoder we spoke about in the last class. So we're going to rerun that, right? So first of all, our label column, we're changing it into 0 and 1, just like we did for early and late, right? So that's exactly what we are doing here. So what you do is you select the column that you want to do that to, which is our churn label here, right? And then replace. So we are assigning it to this variable so that it's replacing this column now. So this column is now becoming what we stated here, right? Now, if we run this, we can see that our data is now. You can also do train the head, though I'm just a fan of test data. So now you can see now that we're having 1 0 0 1 0. Okay. Now the next thing is that we spoke about encoding. So we're only encoding all the columns that are string values. We are not going to encode tenor. We are not encoding senior citizen. We are not encoding this last column here, right? So there's this simple way of calculating the code. You could manually write it out yourself if the data is small, right? But when the data is large, so it's going to take us time to start copying each column name. So what we do is just do this. What it's doing is that we're selecting only the object columns, which are technically columns that are strings, right? And we print it out here. Again, you don't need to cram this code. You can just copy what I have here, or you can just Google it, right? Now, the next is the label encoder, which we did in the last class. What this label encoder is doing is that it's going to iterate through every categorical column that we've listed here, right? And for each categorical column, it's going to encode it, that converts it into 0, 1, and as many as the categories are. Can anyone explain to me how label encoder works? I explained it in the last class. All right, I call on Shola. Shola, deal the class.
All right. Label encoder, it looks at the unique values in that column, and then
Is it my network? Shola, I lost you for a sec. I don't know if it's my network. You said it
okay,
looks at the. Yeah, that's where I stopped.
it looks at the
Okay, is it my network or can anyone hear Shola clearly?
I can't hear it clearly. Seems to be from his end.
unique values
Okay,
in the
okay,
column.
alright. Sure. Okay, yes. So it looks at the unique values in the column, right, and assigns a number to them.
Then it
So for example,
assigns a number to values in that column.
Exactly. So now, following what Shola just said, now this is how this guy works. So we have this column, for example. If we're checking the value counts that we have here, that's the categories that exist here. We are saying that we have no, yes, and no phone service. Now there are three categories here. What label encoder is going to do is that following the alphabetical order, no comes first, of course. So this one is renamed as 0. No phone service is renamed as 1, and then yes is renamed as 2. So it just converts those categories to numbers, basically starting from 0 up to how many categories that exist there. If there are 5 categories, it goes 0, 1, 2, 3, 4. That's 5, right? If there are 10, it will be 0 to 9. That's 10, right? So it just does that for us in alphabetical, following the alphabetical order, right? So that's just how label encoder works. Now we're going to just label encode every column that their names are here, which are technically all the object columns, that are the string columns here, right? So now when we do this is simply a loop. I'm doing this first one for the train data. I'm doing the second one for the test data. Recap. We already divided our data into two, train and test, and these are data frames, right? Now, anything you do on the train data, ensure that you do it on the test data so that it's uniform. The idea of dividing this is that we don't want our model to see what is in this test. We are only going to train the model with this data frame, which is this train.head, right? So we're only going to train our data with this data frame, which is about, I don't know how many samples are here, train.shape, which is about 5,000 something samples. And then the remaining 1,000 something samples, we are going to use it to test the performance of the model. I think someone has a question. Tochiko, please go ahead.
Yeah, please can you briefly explain that particular code again? The train, comma, test, where you
That's
split
this one,
the data
Abi.
sets. Yeah, it's like all those things inside the brackets.
Okay, yeah, let me explain again. So number one, remember that we spoke about dividing our data into two here, Abi. And then I
Yeah,
said that the ideal thing is that initially we have this data of 3 earlies were up, 2 lates were down. Now I said the problem with this is that if we ideally split this data into train, the first one, and then this one into tests or validation, right? The problem is that the model will only learn early and it does not know anything called late. So there's a problem. At the end of the day, we are now going to test the data on something that it did not teach us at all. Imagine a teacher teaching you normal maybe addition and subtraction, and then the exam is now multiplication or division. You're just like, I don't get, right? So that becomes a problem. So now it's important for us to shuffle the data set so that we can have that kind of like look like this, right? That blends in both cases in the train and in the validation. The next thing is that we also need to decide what proportion do we want to split the data by. Do we want to use 70% of our data? Do we want to use 10% of our data, right? Do we want to use 30%, 70%? But because we are using the train part to train the model, it's important that the bigger side of the data is used for the training and the smaller fraction is used for the testing. So that's why in most cases, your train data should not be less than 60% of, I think I mentioned here, it should not be less than 60% of your overall data set. Now let's go back to the code. Now overall data here, which was what we did when we were all doing all of this stuff. Now we want to now divide this data into two parts, the train and the test. Now what we do is just, you can give it any name, we can call this one validation, any name at all, it doesn't matter, all right? So now What we want to do now is that we have train and tests. We call this library here, which does this splitting for us. We input the data that we want to split, which is our data frame, which is this guy here, right? And then anything that you're calling your data frame is what you're going to put here. If you're calling it df, you put df, all right? Now, your test size is what fraction of your data do you want to reserve for testing? Now, if I am doing 60%, right, the test size is going to be 0.4. Do you get? If I am doing 70%, the test size is going to be 0.3. If I am doing 80%, I mean the train part will be 80%, train part 70%, train part 60%. The test size is the remaining balance, which is going to be 0.2, right? So now in the case of this project, right, we chose to use 80% of our data for training and then 20% for testing. That is why we have 0.2, which represents 20% for testing. Then we also mentioned that we need to shuffle the data. By default, this is false, so it's not shuffle. Since we want it to shuffle, we put it as true. So it shuffles the data for us. It shuffles the entire data before splitting. All right. Now, then the last part is the random state. Random state, since remember that this is a random, it shuffles randomly. It's just like when you put something in basket and you shake it, shake it, shake it. So the random stuff. Now, if I want to consistent results, it's important to define your random states such that for any time you rerun this code, the exact way it was randomized before, the exact way is going to return the values, right? So now we set this value to 42. You could choose yours to be 2023. You could choose any number, but ensure that you remember that number because that number is the only thing that is ensuring that random values are constant, right? So that's exactly what is going on here. And now at the end of the day, we've gotten two data frames. The train data frame of 5,634 rows and the test data frame of 1,409 rows. Is that clear? Does that help, Ochiko?
Yeah, very well. Thank you.
Awesome. So now we have our data frame. Again, this is what we're using to train. This is what we're using to test. So now let's go down a bit. We've gotten to this point where we've replaced the churn as 0 and 1, right, for no and yes. Now we also spoke about the label encoder, which basically uses all these categorical columns that we've mentioned here and encodes them to 0 and 1. So you run this and then you run this, you can now see that we are now having zeros and ones. It's no longer these names, right? So this is what our data now looks like. It does not look neat, like it looks so attractive. Now I'm going to give you guys an assignment, or you can not say graded assignment though. I want you to try normalizing or transforming this tenor column so that the values be within range like this one. So you get, and then you compare the results to what we have and see if there's any changes or improvements. I think I should close this. Yeah, any changes or improvements in the outcome of your model. All right. So now we are done with the whole data cleaning. Do you agree? We are done, right? Now we check the distribution of the data. This is the question that Emmanuel asked. We have early and we have late. Now I told you that you need to check the distribution of the data. How many early samples are in your data? How many late samples are in your data? In our case, how many people did not churn? How many people churn? Remember that 0 means no. Remember what did it say? No means that they did not churn. Yes means that they churned. So now we have about 4,000 plus people that did not churn. And we have about 1,406 customers that churned. That's they stopped using this product, right? Now you agree with me that this data is not balanced. Over 4,000 people remained, 1,000 people left. That means the model is likely to learn more of people that did not churn than people that actually churned. Do you guys agree with me?
Yes.
Awesome. So now that means there could be a problem, but let's not bother about this for now. Right. Let's see what the model is even going to do. All right. So now we are done with this upper part. The next thing is that we are now going to define our variables. Remember that what we did here was that we mentioned that this guy is our y, this guy is our y, and these two are our independent variables. So I'm going to single out what our y is so that it's easy for our model to know what is what. So we are going to do x is equals to this train data, which is this, everything here, but drop the churn column. So my train x, that's all my independent variables are every column that is here except this churn column, which is our label, right? Now our y is the churn column, right? Now we do the same thing for our tests, okay? Now the next thing now is that we spoke about feature selection in the last class. Feature selection is now we have about 18 features here, excluding the churn column. Now the question is, are we really going to use all of these 18? Or is there a way we can just pick out the most important features, right? That's what brings us into feature selection that we looked at last week. So I'm going to just run fast on this. What we did last week was we looked at 3 methods. The OLS method, what it does is that it fits the train and X, the independent and dependent variables, and tries to use like a and tries to use their p-value. So the p-value is less than 0.05. We assume that there's a relationship between that column and the label column. If it's above 0.05, we assume that there is no relationship. So we are going to, what's important to us now is columns that are not columns that are less than 0.05, right? So now if we run this is how the result looks like. We are looking at this p column here, right? And then we are checking for their values. If they are less than 0.05, we are retaining them. If they are above 0.05, we are discarding them. So if we do that, all of these columns here are columns that are less than 0.05. So we assume that these columns are important to our label. Another method is this skbest, select kbest, right? This one is one of sklearn's libraries as well that helps us to check or select features based on their k highest score. So it goes with a descending order. So following these results, senior citizen is more important than average charges, right? But then I selected that k should be 12, so I wanted to return just 12 features for me out of the 18, and this is the results. Again, don't stress about the code, but you can just always take a look when when you're chanced, right? So now we have all of that. Then the last method we used last week was the random forest or decision tree. So you're using any of these guys, anyone you want to use is fine. They have this thing called dot feature importance that reveals how important some features were in determining the relationship in the data sets, right? So it's the model that is now telling us, okay, well, I made the predictions, but these were the features that were really important to me. These were the features that I used in descending order. So if we plot it here, we can see that average charges was super important to this model. Tenor was actually very important. Contrast was important, but full service was the least important, right? So out of this, we could select just 10 columns. We could select 5. We could select all of them. It's just random things that we could try as data scientists until we get what works for us, all right? So now, and then now we have 3 methods looking at us here. This visualization, this k-best, and this OLS. Another assignment is that I want you to try the different methods and find out the one that gave the best score. But for this case, for this project, for this class, we are going to be working with what random forest has returned to us, but we'll be working with just the first 10 features. That's from average charges to multiple lines. So now that's the revision of last week. I hope we're all on the same page because we're diving straight now into the proper machine learning. No questions, right? All right, so let's get into the main thing. Now we have our features. That's the columns, the X columns excluding the churn column, right? What we are doing here is basically us selecting or filtering our data frame to become just those columns. So if I run this now, right, and I do this, you can see that these are just the columns and we're now working with. It's also a data frame, right? So we're working with average charges, tenor, blah, 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 until the multiple lines, right? Now, we want to now build a model with this data. We want to be able to predict if this person will churn or will not churn. And we have our train and test Y. Remember that we defined them here where we selected them out. Remember that we defined them here. So our train and test Y, I give it as this train Y. Okay, so recap. We have train data, we have test data. The train data is divided into two, train X and train Y. Why? Because it's easy for the model to know which one is our independent and which one is our dependent. Now, the train Y is the actual data frame. The train X is the actual data frame. The train Y is simply just the label column. Okay. We are going to feed these two guys into our model to learn. And when we are done, we will now tell the model, okay, now make prediction on this test data, which is our filter test X, right? Which you can see as this. Make predictions on this. When it's done making prediction, we'll compare the predictions to the actual test Y, test X, and test Y, sorry, right? And we can now know how well the model learns. Is that clear? Do you understand these basics? Is it clear up to this point? Or is it confusing? This test X, train X, test Y, and all of that? I need a response. I don't want you guys to get lost.
Yeah, it's clear.
It's clear, right? Awesome. All right. If it's not clear, please let me know. Okay, so now we are now going to start with our logistic regression, which we have seen, right? So what we do is from sklearn.linear model import our logistic regression. Okay. Now we now do what we call to initialize, right? What this does is just calling, you only imported it, but you're not referencing it here. So for us to actually make use of this model, we need to call it out here, right? And that's what we do by just doing this. And then assigning to a variable, you can give this any name of your choice. And then whatever name you give this is what you now do dot fit. Fitting now is like it's trying to now learn the best combination, best mathematics, that comes up with a least error, right? So that's what is going on in this case. So we feed in our independent variables and we feed in our dependence variable here, which is our train X and our train Y. Okay, so when you fit this thing, the next part is for us to now check how well did this learn. Can we now use this model to make prediction on our test data, in this case, just the independent variables of our test data, so that we can now compare the prediction, which is Y, to the actual test Y, right? And see if it's actually learnt well or not. If it learnt nonsense, we're going to get a horrible result. then we'll have to come back to looking at what we did here, how we can improve, and we'll repeat the process again until we get to a point where we are having a good result. All right. So now this is it. If we, I'm not sure I run this. So if we run this again, and we run this, then we run this. So now what I did here, basically it's not important, but what I just did here is for us to be able to like compare the model and the prediction that we are getting, right? So now if we are doing what we did here, just to create a new data frame called the test data, which is just a copy of our test X. That's basically the majority of the data frame. Then we create a new column called the actual, which is our test Y values. We create another new column called LR prediction, which is the predictions from this model. Right now, when we run it, you can now see that in the first case, it's correctly predicted this guy, it's correctly predicted the second guy, correctly predicted this one. But when we look at row 5, or rather row 6, right, 1 is predicted here, 1 is the actual value, and then 0 was predicted. These two were correct, but these last two are wrong. Now, on a high level, we've not really gone into details, but on a high level, you could agree with me that it's tilting towards 0 in most cases, right? Does anyone agree with me?
Yes,
Why? Now, defend your agreement. Why?
because many the values in the predictions, many of them are 0 compared to 1. The one there is just only 2 out of 10.
Awesome, you get it. So now I remember that when we looked at this guy, we said that there are chances that we have a problem in our data where we looked at this, right? Now 0 is the majority class, that is, they did not churn. 1 is a smaller class, which is one of the more important class to us, meaning that they churned, right? But now the model has learned so much of 0 that it's literally predicting everybody that they're not going to churn, whereas these guys are likely to churn. Right, so now it's a concern for us, and we'll find a way to fix that. But before we go into that part, this is just an observation. We call it eyeballing in let me just type it, eyeballing in machine learning, when you just using your eyes to make evaluation. Now, in to quantify the results of our model, we make use of what we call evaluation metrics. Right, now I'm going to explain this in details for us. We have 4 major types: the accuracy score, the precision, the recall, and the F1 score. Again, they are the major types, they are not everything, right? Then we have the almighty confusion matrix that just gives us like a visual view of how the model was even predicting. So let me explain it in paper here before we come back to it. Okay, so I'm going to start from confusion matrix because it's the basis for everything. So we have this guy called confusion matrix, right? Now, confusion matrix is just a table or a box or a matrix, anything you want to call it, right? That looks like this. I'm not sure why my hand is slanting, but please pardon me. That looks like this, right? Now, in this case, the upper part represents a class, the lower part represents another class. No one is superior over another, it's just that one will have to come first above the other one, right? So now let's assume that in our case, um, no is coming first and yes is coming next. So we can call this one no and can call this one yes, right? Now we have, we can also call this, yeah, we can call this no, we can call this yes. Now how what we call true positive, and then we have false positives, we have true negatives, and we have false negatives. Now in machine learning, it does not matter in binary classification, it Does not matter whatever your label names are. What confusion matrix is looking at is what class is positive, what class is negative. So technically, the way we rename columns to 0 and 1 when building models, confusion metrics rename them to positive and negative. So these two are simply class names, right? Positive and negative. So the first class again is up, that's all positives. The second class is what's down, that's negative. It does not literally mean that this is a negative class, it just means these are the category names, positive and negative, right? Now, okay, so now what confusion matrix does is that it displays the number to us. Like true positive means that how many people that belong to 0 we actually predicted as 0. It tells you how many they are, right? Let's assume they were 900 from our data sets. So 900 is here. Now, false positive is that how many people were falsely predicted as positive. That means they should have been negative, but were predicted as positive. Do you get? So let's assume now this one is 187. So we have 187 here. I'm going to take questions. I know there are so many questions that you guys will have. So now the true negative is now the same thing we did now. How many people were meant to be 1 that were actually predicted as 1? That's people that were correct, right? Now let's assume this one is 200. Yeah. So you can put 200 here. False negative is that how many people were wrongly predicted as negative? That means ideally they should have been positive, they should have belonged to this class, but were not predicted as this class. So let's assume they are 79. So we put 79 here. So this is what a confusion matrix is. So if you run this in Python, the results may look like this: 900, 187, 200, and 79. This is technically how the results look like. Do you guys have any question so far on confusion metrics?
I understand this confusion matrix, but the only thing I don't understand is what I'm not clear about is the 0 and 1. I know that those
Oh,
are
okay.
Boolean values, but
Oh
0 is
yeah.
this
Oh
standing
yeah.
for true or false?
Oh yeah. I'm going to just undo.
Okay.
Right. What I'll do here is this. Now, to avoid confusion. So now TP basically is how many people were positive and were classified as positive, right? Then false positive is how many people were wrongly classified as positive. That means they should have been negative, but they're classified as what? Positive. Same thing too for this guy. How many people, that's for the down part now, for TN. TN means this one is true positive, this one is false positive, right? Now for TN is the true negatives. Now how many people were negative? They were classified as negative, right? Now false negative is how many people were wrongly classified as negative. That means they should have been positive, but they're classified as what's negative. So this is our true N and this is our false N. All right. So does that help? Take away zeros and ones.
Yes, helps.
Awesome. So now, um, we have another thing. This guy just gives us a visual representation of like counts. Basically counts. It just counts for us, right? This is the numbers. Sort yourself out. Then we have other guys that help us to actually sort ourselves out. We have guys like recall, precision, accuracy, they're the big guys. Accuracy, recall, precision, and F1 score. This is one. F1 score, right? Now, accuracy just tells us that, okay, how many people were correctly classified. I don't really care about whether positive or negative, whether this one is higher than this one, just how many were correctly classified. That's what accuracy is asking. So accuracy just looks at the truths, right? So the formula for accuracy is just summation of all the truths, some truths. This is a horrible formula, please. Then the sum of all the rows, or total rows, whatever, total rows, right? Now, what this means is that CP plus Tn all over the length of the data set, length of the trained data. Now, this will give us all the sum of all these numbers. That we can say CP plus Tn all over CP plus Tn plus Fp plus Fn. You get, and it returns the value for us. That's what accuracy does. Then we have recall. What recall is about is that, now recall asks this question. Remember that we have the churn and did not churn. We have in our data sets, no is equals to 0, right? And yes is equals to 1. Did not churn. Churn, right? Now, recall is asking us that if we're looking at, for example, the people that did not churn, right? Now, how many people that did not churn, we're looking at that column. I mean, the actual people that did not churn, right? Now that's 0. So how many people were having the 0 label? So based on all the whole zeros, right? How many zeros did we now have in our label column, in our prediction column? Like, how many of these zeros was the model able to recall? So it looks at the actual value perspective. So following the actual value now, just like you being a manager, following its actual value, right? How many did the model get? We're looking at the zeros, right? How many did the model get? That's what recall does, right? Now, the formula here is that it looks at the so the formula here is that it looks at the true positives, right, divided by the true positives plus the false negative. That's what it does basically. So what it's trying to be sure is that the false positives are less, right? Now, if it's important for us, I'm going to explain how to know which one is important, false positive or false negative. But if false negative is important to us, use recall. When I mean important, I mean if we want to have low false negative, use recall as your evaluation metric. If you want to have low false positive, use what? Precision as your evaluation metric. Now, what precision does is that based on the prediction, precision is not really looking at the actual, it's looking at the prediction. Based on the prediction, right? For example, for the 0 class, how many of these 0 classes here are actually 0 classes? So like an inverse of the recall. Recall looks at from the actual perspective, right? Precision looks at from the predicted perspective. How many were predicted here that are actually this category, right? So now what precision does is that it uses this formula, CP over CP plus FP, right? That's what it does. So it checks for false positives. Then we have this F1 score guide that we call it the harmonic mean of the precision and recall. So this evaluation metric is most ideal when you have an imbalanced data, like our own problem. So this is the best evaluation metric to use. But if you have a balanced data, it's more ideal to use either of these based on what your problem statement is. Do you get? Do you have any questions so far? I'm going to explain FN and FP now. Like, how do you know if false negative or false positive is important to you? But do you have any questions so far? If it's confusing, also let me know that it's confusing. Yeah, go ahead and speak.
I'm a little bit confused because from the health sector, the way we use it is quite different. So I'm trying to process it, but I know how to get it. Because if we say through positives in health sector, there are people that are actually sensitive to a test. So they are the people that are actually through that they have, let me say, the disease or something. So I'm confused on that section. But maybe if I go over,
Awesome.
I
So
might
now,
get it.
oh no, 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 we're even going to get there because it's a question of now, like you said in the hospital case, the question now is which one is more important to me? Is it false positive or false negative? You agree with me that we can never have a perfect model. But now there's a point where you have to like make a decision because sometimes one value could be higher than the other. You could have a high precision and a low recall. You could have a low recall, a high recall and a low precision, right? So if you're not sure what exactly is working for you, then that's a problem. So how to decide is that again, if you're looking at false positives, precision should be your guy. If you're trying to ensure that you have low false positive, ensure that you have a high precision score. If you're trying to have a low false negative, ensure that you have a high recall score. Now the question is, if you're looking at our churn case, what you ask yourself is, what's the worst thing that will happen in this situation? What's the worst thing that will happen in this other situation? The one that has a more severe consequence is what you should focus on. So now we have a churn case here, right? We want to predict churn. Now we want to decide, is it false positive or false negative that we should focus on, right? Now remember that this is low, that means they did not churn. Remember that what false positive mean is that this guy is negative but was predicted as positive. Negative here is yes, positive here is no, right? So now false positive mean that these guys actually left. Yes, they left, but they were wrongly predicted as positive. They were wrongly predicted that they did not go, but they actually left, right? Now, if we predict that a customer will not leave, whereas they were going to leave, what's the worst thing? Like, what impact does it have on the business? Anybody? Anybody? All right, Tochiko, help the class. So let me take the question again. Question is that remember that false positive. Okay, let me start this way. Tochika, I'm going to come back to you. Emmanuel, what does false positive mean? From my explanation now. Emmanuel Nicole. There's someone I want to call. I've forgotten his name. I'm trying to remember. Yeah, Ahmed. It's you I had in mind. I was trying to come back to check your name. All right, Ahmed, help us. What does false positive mean? Based on what we've
False
explained
positive is
now.
based on one explained earlier. What you explained earlier is when it's like it's a zero, but it's equal to one. Like
Okay, no, wait now. Now, in this case, use positive and negative, right? Now, false positive, what does it mean? Using negative and positive alone.
falsely predicted as positive.
So it should have been negative, but was predicted as positive, right?
Yeah. So it's positive. That's a
Right?
bit
That's what you
confusing for
had
me.
in mind,
I
right?
always like confuse between
Uh,
them.
okay, so now let me take it this way. Now we have false positive. The two words here are what? False and positive. Do you agree?
Yes.
Yes.
Okay, awesome. Now, false meaning that it is not positive. Do you agree?
Yes.
Yes.
Now,
Yes.
if it's not positive, what should it have been? it should have been negative, right?
Yes.
Yes.
Awesome. Now, false positive simply means should have been negative but was predicted as positive. Just take the opposite of whatever this P is. It should have been negative. It belonged to the negative class, but it has found its way to the positive class. Right now, that's an error. That's wrong. Okay, but we want to know how severe is this error. That's what we are looking at now. Now, false negative is false and negative. Should have been positive, but now it was classified as negative. It's a false negative. It does not belong here. We want to know how severe is this error. If you're having false positive and false negative, which one should we pay more attention to? Which one is more severe? Which one will cost us more? It could be life, it could be money, it could be stress, it could be, it could be anything, depending on the use case that we're looking at, right? Now, we have a situation at hand. We are trying to predict if someone is going to churn or not. Our label 0 is what is always going to come first, which is no. Label 1 will come second, which is yes. But let's not stress about these guys. Now back to this guy. We have no and yes. False positive means that this guy is falsely predicted as no. Do you agree? This guy is falsely predicted as no because this column, this line here is for all positive guys. Do you guys agree with me?
Yes.
That yes is not strong. You've gotten confused again, Abby.
No.
I can take it again. Just let me know if you're confused. Okay. All right. So now I'm going to recap, right? Because I know someone is confused, but they don't want to talk. So now false positive, again, we've said it that this guy should have been negative. It should have belonged to this down class, but was predicted as this up class. Remember that everybody up here, right, is technically should have been is seen as positive class as no. Everybody down here is seen as the yes class. Now the problem is these guys here because they are wrongly classified. Okay. Now we are looking at the severity of these problems. Now for false positive, someone is predicted that they will not churn. This no is saying that the guy will not churn. The guy is with us. Someone is predicted as they will not churn, right? But whereas they should have been predicted as they will churn, they belonged down here. Now the question now is that what impact will it have on the business if over 5,000 people are predicted that they will not churn, but they are actually going to churn? What impact will it have on the business? That's the question. Now over to you, Tochiko.
Um, okay. Okay. I think the implication is that okay, whereby you're not like saying that these people, you are predicting that some sets of customers are not going to churn, and then you end up predicting that they won't. I think the implication there is that maybe instead of focusing, like the focus should be on making a strategy that will be able to like convince the people that churn. So instead of, I think the implication here is just okay, like instead of channeling, maybe in terms of resources or something. So instead of you no longer like know or have like a good idea of who you are supposed to focus on. Like they will be sidelined based on your
Whereas you should have
strategy
focused
to
on them, right?
yes, yes,
And that means
yes.
there are
So
chances that
you
we
might
can lose
just
those
go on.
customers.
Yes, just something, yeah, and maybe something similar goes to having is it false true negative? Maybe you
No,
might
no, no. Let's
end
no, no.
up
Let's not go there. I'm going
okay,
to ask
okay,
another person
okay,
that one now.
okay,
Okay. So
yeah,
now, but we all agree. False positive meaning that guys that should have been predicted that they would churn, we predicted that they were not going to churn. So there are chances
yeah,
that if we don't focus on them, we could lose them, right? Now,
okay,
let's assume that eventually we've lost 2,000 customers because of this bad model. Let's assume we're using this model, right, on different customers. Now we've eventually lost 2,000 customers. So now next question now is that for this false negative, right, these guys belong to the up parts, but they were placed down here. So that means these people would have not left us. They were still going to remain with us. We predicted that they were going to churn. So what's the implication? What would have happened? Let's assume we have some customers in this category. What's the implication of this one? All right, so Shola, over to you.
Okay, so in this case, that is the model predicted that the customers are going to churn. Meanwhile, they are not going to churn.
Mm-hmm.
Um, I think it will just be like a waste of resources that the company is going to use to prevent those customers they think will churn. Meanwhile, when they are not going to churn. That's what
Yeah,
I
so
think.
we're going to probably spend more time sending them emails, sending them happy birthday wishes, maybe all of those kind of things that we can just do to keep. And on the other hand, the customers will be like, this company is good though, right? And they may, in fact, it may even strengthen their loyalty. Do you get? So now I want you guys to now judge between this FP and FN, which one is worse? Who will I call? Wait, let me call somebody. There's someone I've not heard their voice. I mean, basically just this. Okay, Emmanuel then.
The last one is false positive.
So the false positive is more severe, right? So it's important that we have a high precision score, right? So we're going to be looking at the precision. Precision is like our major focus. So we're going to ensure that we have a high precision score, meaning that we have a low false positive. Now, is this clear? Does everybody understand?
Yes.
Yeah.
That yes is having so many S.
Yes. Yes.
Okay. All right. Awesome. So let's go back to our code, right? So now we are here. This is the confusion matrix, right? If we run this on our code, we get this value, just the way we've explained. Now when we run this precision score, we get this value. Remember that the higher the precision score, the better for us. Okay. When we run the recall score, we get a higher recall score. Now when we run this F1 score, which is like a harmonic, there's a formula for this, but I've forgotten. But I think it's either 2 times precision plus recall all over precision times recall, or the other way, or something like that. I'm not really sure. But yeah, so then when we run this guy, it looks like this, right? But remember that the major concern for us is this guy, and there is a problem. Okay. Now, one thing I want us to do next is what we call debugging, trying to like figure out where the problem is coming from. I don't want to use a simple data. I want to use like an actual data that, this looks like what you can get in the real world. Now, there's this thing I personally do. What I do here is I try to make a prediction on the trained data itself. Remember that I said that you should always predict on the test data, right? But now I predict on the trained data. Can someone tell me why I do this? Like, what's the idea behind this? Tell me why do you think, like, what do you think could be possible? Like, what insights can we possibly derive from doing this? Like, predicting on the trained data. Yeah, go ahead and speak.
Predicting on the trend that is more than the test data, so it will give me more overview over the model.
Awesome. So now it's going to tell us, did the model even learn this trained data itself? Right. It's just like, for example, I'm asking, I'm a parent, I sent you to school, and then over the weekend, I'm going through your notes. I saw that they taught you 2 plus 2, and I just want to like test your knowledge. And I ask you, okay, oh yeah, Tochiko, 3 plus 3 is what? And then Tochiko is fumbling, just the way most of us did when we were small, right? Now Tochiko is trying to like understand what I'm even asking. And I'm like, okay, now let me follow what they taught in your note. Now 2 plus 2 that they taught you in class. What is 2 plus 2? Now if Tochukwu can tell me that 2 plus 2 is 4, I get an idea of where the problem is coming from. Maybe I now understand that, okay, all he learned was 2 plus 2 is 4, and he's finding it hard to generalize to other summations like 3 plus 3 or 4 plus 4, right? Right. But if I ask Tochukwu 2 plus 2, which was in his notes, and he cannot even remember it, then I know that there's a bigger problem, right? The problem is that he did not even understand what was taught in class. Do you get? Now, the idea behind this is that if this model is performing so well on my trained data, right, then I know that it's really learned this trained data, probably even crammed the trained data, and it's having difficulty generalizing on the test data. Then how to solve that one is different. But if it did not even learn anything on the trained data, it will give me a poor result on the trained data. Then I know that, okay, the problem is that the model is not even understanding what is going on in the trained data, and that's a different problem. Now, when we have a situation where the performance of the model is bad on trained data, we say that the model is underfitting. I think I had a plot here. Yeah, this one. Now, the difference between underfitting and overfitting is that the test error, how do I explain this? Now, the training error or the performance of the model on training data is actually poor. So the error on the training data is actually high. You can see that is high, right? Now, but for underfitting as well, since the performance on training data is even poor, that is, the error on the training data is high, therefore, the error on the test data will also be high. Do you agree with me? If you did not learn anything in the train, it cannot know anything on the test data. You agree, right?
Yes.
Awesome. Now, on the overfitting side of things, that's the second half here. The error in the train data is very low. That's it really, really learns the train data. Like if I should evaluate on the train data, I might even get as high as 90 something percent, right, to show that okay, it's really learned this stuff. But when I evaluate on test data, the error is high. So that means it overlearns the trained data, but cannot generalize on a new data set. So now let's go back to our problem. So when we run this guy, we can see now that the F1 score is barely around 50%. That means it did not learn much, you get. So we are having a problem that was. So do we have an overfitting or an underfitting problem here?
Underfitting.
Underfitting, awesome. Now, there is a way that I went about solving this problem. What I did was I tried to now balance the data sets. Remember that the gap we're having in data could be a problem. So there is library again called random undersampler, because I'm trying to reduce the data. I want the 0 and 1 to be equal. So I want to reduce the 0 samples. I want to reduce the 0 samples, right? So that I'm now picking random 1,496 samples from this guy, so that we are having both 1,496 on both sample on both classes, right? If I went through the oversampling route, it is me trying to increase this guy to meet up to this guy. And what they use is synthetic data. So it's better for us to try with an actual data set, considering that we even have a big data to an extent, right? So we'll see what we're going to get, right? So now let's do that. So we're using this guy called the random undersampler here. And this is a simple code. What it's doing here is just basically this. We initialize this random undersampler with our random states. Remember that it's randomizing. So we want to ensure that each time we run this, it gives us the same random values, right? Then we do this, which is simply fitting this sampler to our data, our tests, our train X and train Y. Again, we are not going to tamper out our test X because that's the major thing we're using to evaluate, right? So we're working with only the train data set. Now, if we run this, we can see that this was what we had initially. This was the size we had initially, and this is the new size now. So both 0 and 1 have the same number of rows. Is that clear up to this point? Any questions?
Can you take that section again?
Okay. All right. So what I did here is what we call random undersampler, right? So the idea is that considering that we have a problem with our imbalanced data sets, right? We want to now we want to make them equal. Now we have two choices here. It's either we add more samples. Should I write? So for oversampling or undersampling, we have this guy. We have our data of this distribution, right? This is 0, this is 0, and this is 1. I should have done the other way around. Now this is 0 and this is 1. Now this one is about 4,000 samples. This one is just about 1,000 samples, right? Now there are two things we can do here. It's either we add more blocks here, right? So it can increase to these heights so that they're equal. Or we try to like reduce this guy to say we try to like reduce this 0 guy so that what we have here is equal to what we have here. Do you get? So there are two options for us. Now considering that the entire data set, the smaller data size is about 1,496. That's for this one column, for this one class. It's actually high enough. So we have another 1,496. We should be having a data of almost 3,000 samples, which is not bad. So maybe we can take the route of reducing the data so that both are equal. Now, if we are doing that, we call that undersampling because we are reducing a particular sample size. This one has more. We are now reducing it to this, so it's undersampling. But if we choose to go to this route of increasing, we call it oversampling. Now, what I said is that it's easy for us to undersample because, again, we have many data. We can just choose, we want just 1,000. We can just pick 1,000 random samples from what we have. But if we're oversampling, we don't have any existing extra data for this. So we use what we call synthetic data, right? That creates like a form of how these classes look like and generates new data sets for us. They're synthetic, they're not real. So what I said is that since we have a large data set of that we're going to get up to 3,000, then it's ideal for us to just do this undersampling. But if we had a smaller data set, then maybe we can go through the oversampling route. Is it clear now? And that's what this code is doing here.
It's very clear. Thank you.
All right. So now that's what this guy is doing here. I remember that we mentioned about the random state, so that each time we run the random 1,000 whatever samples that are selected, it is the same random rows that are going to be selected. Then now we have a balanced data of 1,496 for class 0, 1,496 for class 1. All right. Now the next thing, don't worry, we're going to round up. Let's see if we can get done by 1. So the next thing now is the logistic regression. We are going back to do what we did before, which is this. We're going to rerun again, right? Now, when we try this guy, now remember that I mentioned that F1 score is ideal when you have an imbalanced data, right? But when you have a balanced data, then it's important to just choose the one that we're focusing on. Our major focus is to have a lower false positive. So precision score needs to be high. That is very, very important to us. Our precision score here was 0.49, so we're trying to increase it, right? So now we remember that this random sampler renamed this for us. So our filter train X is technically this X-res. Our train Y is technically this, but they are still data frames. If I do X underscore rest, we have this still a data frame. Do you get? So now what we are doing now is that we want to now do our normal training. Remember that before we did dot fits train X and train Y. So that's what we're still doing here, which is X res and Y res, right? And now we're now going to do our prediction. So our prediction now is we're going to try both our tests and train predictions to check if it's underfitting or overfitting. So now this one is for the train data. We are predicting on the train data when we fed here, right? So if we run this now, we can now see that before we had 0.54 on our train data. Now we're having a precision, okay, although this was F1 score, but now we're having a precision of 0.36, right? Now, if we run, now we can go ahead and check the precision on our test data sets, right? Now, if we are running on our test X, the way we did here, right? Remember that predictions here was called, the prediction here was where this guy predicted on our test X, right? Now we're going to do the same thing again here with our precision score. Now we're going to do the prediction on our test X, assign to a variable called test underscore prediction, then compare this test underscore prediction with our test Y, just the same way we did here, right? Now if we run this, you can now see that we have a significant improvement on the performance of our model. Previously, we had 0.49, approximately 0.5. Now we are having 0.85. Now we can see the importance of having a balanced data set and the importance of, the whole debugging of your model, understanding how it works, where the problem is coming from, and all of that. Now, just the same way we did logistic regression, in the same way you can do any other model that you want to try. Import the model, call it here. I saying the same thing, fit it, right? Do your prediction. In our case, remember that ideally you should do your prediction on your test data. So don't go and make mistake and do this and submit your results as this. It will be wrong, go. So ensure that this is the main thing that you're focusing on your test data, right? So you do your prediction and then you do your evaluation. All right, and this brings us to the end of this class. So before you ask me questions, let me give an assignment. I am not going to grade, but just if you want to try things out personally, right? I want you to try out these two features, the one from OLS and the one from KBS. Remember that the features we used are these ones from the random forest, right? And see the impact on the performance that you're going to get, right? And then also see if you can also transform this tenor column and see the impact there, if you're going to get a better result or a worse result. And last thing I want to note is that in machine learning, you try as many different algorithms that you can try. When you're done, you pick the one that gave you the best performance. Like you can see that the logistic regression model is performing better than this support vectors model, right? So that's just the idea of everything relating to an ML model in terms of a supervised classification task. So yeah, any questions?
Okay, yeah, thank you very much, Sharon. I don't really have a question. I would maybe go through the recording later on to consolidate what we've done so far. Yeah, so
Awesome.
can we get the script, the notebook, maybe
Yeah,
a
I think
copy
I
of it?
shared it the other day. Let me see. I think I
Okay.
have.
Shade shared it on our channel.
Oh,
It
oh, I
was
Yeah,
must
it's on the
have
it
missed
channel.
was
Yeah, in the
that.
same notebook. Yeah,
It's
you
still the
find it
same
there. The
thing.
data is also, yeah, it's the
Okay,
same notebook. So it's a
okay,
drive. She shared the folder link with you. So you'll see the data there. You'll see this notebook inside there as well.
o- okay, okay. Thank you so
Yeah.
much.
All right. So welcome. So no other questions, right? Feel free. Ahmed, okay, was it Ahmed that spoke? Okay, so Ahmed that spoke. All right, so yeah, I think this brings us to the end of the class. Thanks again for joining.
I have a question, sorry. You don't mind?